Internet of Things and Industry 4.0 create global supply chains and are turning our world into an information economy. As a result, global security and data standards are required. Only then can we ensure that the market develops confidence in new products and services, and that companies can pass this confidence on to the consumers. Due to the specialized vocational training and the superb network of universities in Germany, including the research facilities that deal with Industry 4.0 and the Internet of Things, combined with our experience and quality, Germany is in an ideal position to attract the best and brightest in the future.
German research institutes are amongst the world's leading pioneers in taking on the challenges of Industry 4.0. The German Research Center for Artificial Intelligence and the Smart Factory Kaiserslautern have partnered with industry to build the first cross-vendor Industry 4.0 installation. This demonstrates how sophisticated information technologies are integrated into factory automation.
Industry 4.0 is a networking vision. It only works in a network. We need to connect partners within the network, and these partners must speak the same language. This not only applies to human communication, but also to technologies. Our machines have to speak the same language. As a result, we have to create standards, and the standards can only be developed together. This is one of the focal points we are addressing.
The Fraunhofer Institute is internationally renowned for its comprehensive Industry 4.0 research. Intelligent production lines for the automotive industry are being developed at the Fraunhofer IWU. Sensor networks allow for the flexible production of different car body styles on the same production line.
Wir werden in einer Prozesskette, zum Beispiel im Automobilbau, von einem
In the future, we will have more flexible processes. Think of the automobile sector, for instance. From a supplier of steel that makes car body parts to an OEM right through to the car dealership. We will see cost reductions, shorter time to market times, and great potential for optimization in general.
Also ein hohes Optimierungspotenzial heben können. Wenn wir die Daten später quer zu den Branchen.
If we compare the data across different industry sectors, for instance, and connect vehicle and meteorological sensors with the weather forecast or insurance companies, we gain new insights and develop entirely new business models by centrally analyzing and correlating these large amounts of data.
Völlig neuen Erkenntnissen kommt.
For the government of the Federal Republic of Germany, Industry 4.0 is a key element in securing Germany's status as a manufacturing location.
Germany's key advantages are its highly developed industrial landscape and the industries which exist here and not in other countries. Therefore, Germany has excellent conditions for the development of Industry 4.0. The federal government supports these developments with funding. Examples are the aviation and space industries, smart grids, or the maritime industry. There are many specific programs to promote the development towards Industry 4.0.
Germany Trade and Invest is the investment promotion agency of the Federal Republic of Germany. The people at Germany Trade and Invest are the first point of contact for international companies looking to enter the German market.
We can help companies develop their strategy for entering the market in Germany. We also provide German tax and legal information, as well as information on possible EU funding, federal funding, or funding from the federal states. This extends to assisting companies in finding sites and discussing their requirements with the federal states to see which one will suit the company best.
Investments amounting to 40 billion euros are planned by the year 2020. Within the next 5 years, more than 80% of German companies will fully digitalize their value chain. Experts expect an increase in efficiency of 18% and cost reduction of about 13%. Through innovative new products, new services, and new business models, an additional growth potential of up to 425 billion is expected by the year 2025. Let's shape the future together and be part of the fourth industrial revolution.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first SIMATIC. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. However, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber-Physical Systems. Das heißt, Sie haben autokrate selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen.
Samindh, you can remove the screen now. Hi, good morning, everyone. And I welcome on behalf of the Federation of Chamber and Industry and our partners, you for this event. As you aware, we have given you a lot of information how to participate in this one. We take this as a serious event, so therefore we cannot allow some of the people who's in the waiting room. Still, we cannot allow because we do not know them exactly. So we are sorry about that. However, it is we thought I will not going to talk about the industry 4.0 or anything like that. I will just mention, how this happened, how this cooperation came together. Myself, Sena and Nihal, so we have been working on different projects for a long time. So when we are discussing the current issues of the country, we found industries facing a bigger problem right now with regards to the Sri Lankan economy is not really doing well. Sometimes the government cannot support some of the industries when they are finding really hard. With all that, we thought coming together and doing something good for the industry will be the best thing at this hour. Have this in mind. So we thought that we will go for a event like this and see that the industry benefits, and out of that one we as organizations how we can support the industry by doing such a forum. Now if we take about why we need this one, we'll speak in the coming presentations. So when we see today's situation, the biggest issue for every industry today is that if you're not going to get into the global value chains soon, you'll be left out. So therefore, it is paramount important that all the manufacturing units, so they should be very productive, and in the meantime, they should be attending the or joining the global value chains very fast. If not, it will be very, very hard for them to catch once the other countries, especially the developed countries, when they set industry 4.0 technology and when they go for mass production. So it will be hard for especially for the industries in countries like Sri Lanka. So we'll go to the agenda. I will not go in for much details. So let me introduce our first speaker, the president of the Federation of Chamber of Commerce and Industry, Mrs. Shirley Jayawardena. She started her career in business as a businesswoman. She started Media Vision Private Limited that publishes Candy News, the oldest regional newspaper in the island. At present, she functions as the chairperson of 2 global trading companies based in USA. She is a member of the Institute of Management of Great Britain. Shirley started her career at Central Province Women's Chamber of Industry and Commerce, Central Province Chamber of Commerce and Industry. She served as Vice President of the South Asia Women's Development Forum, Executive Committee member of SAARC Chamber of Commerce and Industry, Vice Chair of the Sri Lanka chapter of SAARC Council of Women Entrepreneurs. She is the current president of the Federation of Chamber of Commerce and Industry of Sri Lanka, the apex body of Sri Lankan Chamber Movement, which was established in 1973. This is the first time in the history of FCCISL, a woman entrepreneur takes over the presidency. So let me present you Shirley Jayawardena to make a formal welcome address.
Thank you, Kirti. Thank you for your introduction. Can you hear me?
Yes, can.
Yeah, okay. Aibo Eva, very good morning to all of you. First, let me extend my appreciation to Western Sydney University in Australia, Sri Lanka Institute of Information Technology, National Cleaner Production Centre, Business and Industry Development Services for joining with FCCISL today in organizing this webinar, which is of the very important subject, transitioning Sri Lanka manufacturing into an Industry 4.0 setting. I warmly welcome Professor Amir Mohammed, Professor Nimal Rajapaksa, Dr. Rama K. Ramanathan, Dr. Premaratna Samranayaka, Professor Chandra Pereira, Engineer Sena Piris, and Engineer Nihal Pure from this organization. I also warmly welcome them. I extend my appreciation for giving the fullest support to our SVP, Mr. Kirti Gunadhan, who has professionally organized this webinar, taken so much of efforts. Thank you so much. And today we have a good participation, and I very warmly welcome them. And I must also tell them that we will continue to organize this kind of seminar jointly with this institution. So wish you have an enjoyable session.
Thank you, Shirley, for your welcome address. So let me introduce our second speaker, Professor Amir Mohammuddin. Professor Amir Mohammed is a Master and PhD in Economics from the University of Manitoba, Canada. Professor Mohammed served as the Vice Chancellor and the Chief Executive Officer of the University of Newcastle in Singapore. He led the University of Newcastle, Singapore to win the inaugural Education Investor Asia Higher Education Institute of the Year in 2018. Over the years, Professor Mohammed has taught an undergraduate, postgraduate, and doctoral level across economies, international business, and general management areas in Australia, Canada, Malaysia, Singapore, and Hong Kong. A recipient of Australian Government Endeavour Malaysia Research Fellowship, Professor Mohammed has an active research track record in the field of economics, business, and management. Professor Mohammed has also worked in projects funded by international and national organizations such as World Bank, Agriculture Canada, Canadian International Development Agency, the Development of International Development DFID UK, and the Workplace Safety and Health Institute of Singapore. And he has a very vibrant experience over him, academic and a practitioner. So let me invite Professor Amir Mohammed to make your opening remarks.
Thank you. Thank you so much for this introduction. A very good morning to my friends and colleagues in Sri Lanka, and a good afternoon to my colleagues in Sydney. These are challenging times, and I really hope that you and your family, wherever you are doing well. Western Sydney University School of Business is a successful example of cooperation, collaboration, and co-creation. And to me, today's event is no exception. I would like to thank the Federation of Chamber of Commerce and Industry of Sri Lanka and the Sri Lanka Institute of Information Technology for working with School of Business in organizing this webinar for businesses and industry in Sri Lanka. I must highlight that we are very proud of our deepening and expanding collaboration with the Sri Lanka Institute of Information Technology. They are a very valuable partner for us. Now, whether we are academic, are representing professional bodies industry, businesses, NGOs, there's a common thread that connects us all, and that is our passion and commitment to make a difference. When I talk about impact or a difference, I mean societal, cultural, technological, academic, and economic impact. We want to make sure that that impact is felt at individual, enterprise, industry, regional, national, and international levels. These are challenging times. The changes in the external environment are rapid. The shelf life of new technologies, new knowledge, a new business model is getting shorter and shorter. Industry 4.0 will have a profound impact on careers, professions, and all sectors of the economy. What we're seeing now, that COVID-induced digital transformation is having an added impact on manufacturing and services sector in developed as well as developing economies. So Sri Lankan manufacturing sector is no exception. The timings of today's event is fitting. The objective and the intended outcomes of today's webinar are also aligned with the strategic directions of the Sri Lankan manufacturing sector. The School of Business is working with our international partners in Southeast Asia and also in South Asia, expanding its work and expertise in Industry 4.0 through executive development, training, short courses, consulting, research, and academic collaboration. Today's event is our commitment to assist, but also to learn from the dynamics of Industry 4.0 in Sri Lanka. The exponential technologies embedded in Industry 4.0 will play a key role in manufacturing firms to create, to sustain, and to enhance their competitive advantages. Industry 4.0 is already acting as a game changer and a huge equalizer for SMEs, and not only for SMEs, but also for large manufacturing firms. It is in this context that I see that this workshop is a very important step in the right direction. And the School of Business look forward to working very closely with our partners, friends, and industry in Sri Lanka. Finally, I would like to thank again the President of Federation of Chamber of Commerce Industry, Shirley, Institute of Information Technology, and our speakers to ensure that today's event is a huge success. My very special thanks to my colleagues from School of Business, Professor Rama and Dr. Prem, for their commitment, and just not a commitment, it's their passion for capacity building in Sri Lankan manufacturing. Thank you.
Thank you, Professor Amir Mahmood, for your valuable, opening remarks and your commitment to support our endeavor to support the Sri Lankan industries. We, as a chamber, and two professional organizations together, to universities, going to support the industry will be a very significant thing in Sri Lanka. Actually, as you rightly said at this hour, so this we should take as one of our support activities towards the industry to come up and join the global value chains. Thank you, sir. So let me introduce our next speaker, Professor Nimal Rajapaksa. Professor Nimal Rajapaksa served as the professor in School of Engineering Science at Simon Fast University, Canada since 2009. He was a professor in Department of Civil Engineering at Peradeniya, and Department of Mechanical Engineering at the University of British Columbia. He has extensive experience in academic administration, having served in administrative roles in 4 research universities in Canada. Professor Nimal Rajapaksa is the current Deputy Vice Chancellor of Sri Lanka Institute of Information Technology, SLIT, and Professor of the Civil Engineering. So let me invite Professor Nimal Rajapaksa to make the opening remarks.
Thank you very much. Good morning, everyone.
Morning.
Mr. Shirley Jayawardena, President of FCC ISL. Mr. Keerthi Gunawardena, Senior Vice President of FCC ISL. Professor Amir Mohammed, Dean, School of Business, Western Sydney University. Professor Rama Ramanathan, School of Business, Western Sydney University. Professor Chandana Pereira of SLIIT. Distinguished speakers, ladies and gentlemen, it's a great pleasure for me to say a few words on behalf of Sri Lanka Institute of Information Technology. We are very happy to partner with FCC ISL as well as the Western Sydney University to organize this webinar. And in fact, activities like this reflect on the ethos of actually SLIIT. Going back to 1999, ours is an institution that was actually created to meet the needs of the industry. At that time, we were looking at the needs of the information technology industry. There was very little human resources trained in Sri Lanka in those times, and the information technology industry was growing. And SLIIT was seen as the solution to this. And I think over the last 20 years or so, we have done our job very well. And to the extent that nearly half of the IT professionals serving in information technology in Sri Lanka are either graduates of SLIIT or have some interactions with our institution. And so based on those successes over the last 20 years, we have also expanded the areas of programs in our institution. We have gone into engineering, we have created the School of Business, and very recently we have created a Faculty of Humanities and Sciences. And I'm very much happy to see that our Faculty of Engineering, working very closely with organizations like FCC ISL, as well as international partners like Western Sydney University, to develop programs like this. And as Professor Mahmood mentioned, this is the way the business should be done. And the university should not be just simply ivory towers. They should go out and interact with industry, business, and make sure that we are also actually contributing to the development and the economic growth of our country. Right? That is actually an important role of a modern university. And this particular area that we are going to focus on this webinar, which is transitioning Sri Lanka manufacturing to an industry 4.0 setting. I think this is a very important one because Sri Lanka, we know, is not a very large manufacturing-based country, but we have a lot of potential. Because we have human resources, we have natural resources, and various other important things that can position us to be a power in manufacturing. And so in that regard, I think looking at modern technologies, I look at Industry 4.0, it talks about the smart manufacturing for the future. where you couple advanced manufacturing techniques with Internet of Things and various other advances in IT to make manufacturing very efficient, very profitable, right? And so on. So I think this is an area that is extremely relevant to Sri Lanka, because as you know that we have a very successful garment industry. We also have some very specialized industries, for example, in tires and various other areas. And so these are the areas, and also I must say that the agri-industry in Sri Lanka is an area where there is a lot of potential. So I would like to see that through this discussion and the speeches that will take place today, that will contribute to the growth and the development of the manufacturing sector in Sri Lanka. And once again, it's a great pleasure for me to participate in this. And I thank Professor Rama Ramanathan. He was actually my senior during our graduate studies. We did our master's and PhD at the same institution, AIT in Thailand. So he was my senior. And then also Professor Chandana Pereira, who is my colleague at SLIIT. And I also want to thank the FCCISL and the other partners actually coming forward to work with universities. I think that is the way forward. And I wish you all the best and every success with your endeavors. Thank you.
Thank you, Professor Nimal Rajapaksa, your encouraging words and the support. Actually, if we take this forum today, it's a pool of Sri Lankans. All of them studied in Sri Lanka using the local universities and the knowledge initially obtained in Sri Lanka and gone to different parts of the world. So that's how we managed to get them on board together. So they had the interest, a common interest to develop Sri Lanka, support Sri Lanka in that initiative. These collaborative initiative of the Federation of Chamber of Commerce of Industry Sri Lanka, School of Business of the Western Sydney University, Australia, and the Faculty of Engineering of Sri Lanka Institute of Information Technology. So let me introduce our next speaker, presenter, Dr. K. Ramanathan. Dr. K. Ramanathan is a product of St. Benedict's College, Colombo. His bachelor honors degree is in mechanical engineering from University of Ceylon, Peradeniya. And master's and doctoral degree are the industrial engineering and management from the Asian Institute of Technology. Dr. Ramanathan was with the School of Business at the Western Sydney University, Australia from 1998 to 2006 before joining the United Nations. From 1989 onwards, Dr. Ramanathan worked as associate professor at the School of Management of Asian Institute of Technology at Bangkok, Thailand. He helped to design and run the MBA and PhD programs in management of technology. He's an expert in technology management at the United Nations Economic and Social Commission for Asia and Pacific, that is UNESCAP, on the Japanese government-funded Technology Atlas project. During his service to the United Nations, Dr. Ramanathan has designed and implemented capacity building programs in the area of technology transfer and technology policy for science and technology for ministries, government agencies, business associations, SME support agencies, and R&D institutes in over 15 countries in Asia Pacific region, including Islamic Republic of Iran, China, countries in SAARC and ASEAN, Mongolia, Fiji, and Papua New Guinea. Dr. Ramanathan's research and consulting interests are mainly in the field of management of technology, logistics, supply, and chain management. Currently, his research and international consulting focus is on the transfer of application of Industry 4.0 technologies in operations in supply chain management for enhancing competitiveness and promoting a circular economy. Let me invite Dr. Ramanathan, popularly known as Rama, to start his presentation. His today's topic is an integrated approach for assessing Industry 4.0 readiness of the firm in the manufacturing sector. Over to you, Dr. Rama.
Thank you very much, Mr. Kirti Gunawardena. Good morning, ladies and gentlemen. I can't tell you adequately in words what a great privilege and honor this is for me to be in the midst of all my fellow countrymen from Sri Lanka and, of course, all my former colleagues and good friends. It is truly a great privilege to be with all of you to share some of the ideas that I have gained over the years working for several universities and also for the United Nations. But before all that, what I would like to say is that I learned a great deal about businesses during my nearly 14 years with the National Institute of Business Management in Sri Lanka. I was with the NIBM till 1986. And during that period, I learned a great deal from very fine colleagues there and my mentors. And it is with great pleasure that I acknowledge that much of what I have done is due to that fantastic foundation that I got at the National Institute of Business Management. I have many people to thank, but I will do that towards the end of my presentation. So I would like to get started. And may I ask whether you can see my screen?
We can see your screen.
Okay, thank you very much. Let me start off by saying that my topic, although is on an integrated approach for assessing Industry 4 readiness of a firm in the manufacturing sector, I would like to say with all humility that there is so much more than what I'm going to say today. We would be barely scratching the surface because it is such a vast area, but I'll try my best to cover some of the more important aspects. I would like to make my presentation in 5 parts. To start off, what I would like to do is have a quick overview on Industry 4.0. This would be necessary to make sure that everyone is aware of some of the basics of Industry 4.0. I'm sure we have many experts in our midst, but there may be also others who are really not from the engineering side or the production side. So I think it would be useful to have a very quick overview of what we mean by Industry 4.0. Having said that, I would then like to spend a few minutes talking about the implications that that Industry 4 is likely to have for emerging economies. Having hopefully made the case that emerging economies need to embrace Industry 4.0, I would then like to spend some time talking about how a manufacturing firm in an emerging economy, or for that matter, even in an advanced economy, could assess how ready they are to embrace Industry 4.0. And we have developed a very simple framework which can be used by management in a company to quickly assess Industry 4 readiness. And I'll speak about how it can be done. Now, having presented that, let us assume that a firm has assessed its Industry 4 readiness using the framework that we have proposed. The question then arises, what next? How do we use the findings to move forward? So I'll talk about that a little bit after as my fourth part of this presentation. And then I will make some concluding observations before I hand it over to my esteemed colleague, Dr. Prem Samarnayaka, who will then continue by talking about a case study that he and I did in a company to demonstrate the Industry 4 readiness framework. So that would be my plan of presentation. And I'll start off by talking about Industry 4.0, an overview. Now, Industry 4.0 is often referred to as the fourth industrial revolution. And as Professor Rajapaksa pointed out, it's going to have a very big impact on manufacturing value chains, not just in advanced countries, but also in many emerging economies. The term Industry 4.0 actually originated in Germany way back in 2011. However, it became very popular when it was introduced at the World Economic Forum in 2016. And since then, it has captured the imagination of business leaders, government policymakers, and academics throughout the world. Now, one of the reasons why Industry 4.0 is referred to as a revolution, a fourth industrial revolution, is because Industry 4.0, like the three previous revolutions, which I'll talk about in a minute, involves not only disruptive technologies, but also is a revolution in terms of the managerial innovations that are needed to use these disruptive technologies with effectiveness. And that is one of the reasons why the term revolution is used, because it requires a completely new way of thinking and working. It is not just a question of embracing technologies, new technologies, or adopting new technologies, but continuing with the old way of working. It requires a completely new way of working as well. And that's one of the reasons why it is referred to as a revolution. Now, this is a simple depiction, and many of you, I'm sure, have seen this before. When we talk about a fourth industrial revolution, there is an implication that there have been three earlier revolutions. The first industrial revolution, as all of us know, came about during the Industrial Revolution in Europe, which involved the use of steam power, mechanization, the weaving loom. And this went on for many, many decades. And then there were many innovations that came about, many technological innovations and also managerial innovations. And then this led to the second industrial revolution of mass production using an assembly line. And this became feasible thanks to the availability of electrical energy in a commercial way. And here again, innovations continued both technologically, managerially, the way business is run. And then we moved on to the third industrial revolution, which was just a few decades ago, where computers, electronics, automation, and other related innovations, technological innovations came in. And this again led to businesses adopting completely new ways of working. The online e-commerce, many of these things became possible thanks to Industry 3.0. And this became possible because of computers and communication coming together. And that is one of the reasons why, instead of simply saying information technology, today we talk about information and communication technology. And Industry 4.0 owes a lot to many of the technological innovations that came about during Industry 3.0. But now we have moved into a completely new way of working, where we have now what we call cyber-physical systems, Internet of Things, networking, and all these became possible thanks to the introduction of what we call, or the availability of what we call foundational technologies or exponential technologies, as Professor Mahmood mentioned during his speech. Now, these foundational technological advances include many things: Internet of Things, big data and analytics, simulation, artificial intelligence, additive manufacturing or 3D printing, and many other technologies. In fact, here's a simple diagram which was put out by the Boston Consulting Group a few years ago, where they talked about what they referred to as foundational or exponential technologies. And Industry 4.0 really hinges on the adoption of many of these foundational or exponential technologies to carry out business in a completely new way. So we have things like the Internet of Things. We talk about system integration, simulation, autonomous robots, big data, augmented reality, additive manufacturing, sometimes known as 3D printing, cloud computing, and advances in cybersecurity. All of these have come together to enable companies to work in completely new ways, creating value not just for their own stakeholders, shareholders, but also for customers as well. Now, really means we are talking about smart production systems. And smart production systems basically enable companies to very quickly respond to changes in demand, supply fluctuations, machinery breakdowns, and so on. So it's very responsive. Manufacturing becomes very responsive. Then we have what is called horizontal integration, where a single entity, so for example, in vertical networking, if you take a single factory, and when the machines within the organization, within that particular factory, start behaving in what we may say a very smart way by being very responsive, we can now extend that further to other entities in the supply chain, where right from inbound logistics through manufacturing and eventually to sales and after-sales service can all be networked. And this networking is done in a very transparent way with great flexibility, traceability, and optimization across the supply chain. So this is another important attribute in the Industry 4 setting. Furthermore, what is now possible is that new products and services can be designed by collaborating with all the partners in the supply chain in a very seamless way. And this is referred to as through engineering. And the use of the foundational technologies such as robotics, advanced robotics, artificial intelligence, nanosensors, and many of the other foundational technologies that we talked about can all lead to greater flexibility and cost savings along the supply chain. Now here's a very simple diagram which shows the traditional or pre-industry 4.0 supply chain, which Inomata refers to as the snake. So you can see here where the product development, product design, research and development, all this takes place in a very linear way, going right through to assembly, logistics, sales, going up to the consumers. So here we find a very linear flow. So this is the linear model or the linear supply chain, which Inomata refers to as the snake. But with an Industry 4 setting, what Inomata says is that we move from the linear approach to a very different approach here, where it's very collaborative. And we have here the firm at the center. He refers to it as the control tower. And all the early activities that were there in the snake-like supply chain now can happen simultaneously without having to go through that linear pattern. The advantage in this is that a lot of the time taken to respond is cut down quite dramatically. And this leads to very great advantages, enabling companies to become more agile, more responsive, and to be able to meet the needs of their customers in a much more cost-effective way. What are the advantages of Industry 4.0 from a very simple business perspective? Firstly, Industry 4.0 enables improved product design and customer relationships. For instance, products can be customized, meaning that we don't have to produce something of the same type and tell the customers, I mean, this is what you have, we have, take it or leave it. We can actually customize. So we can move not just from mass customization, which is now prevalent, to what is even called individual customizations. So we can design, we can actually include the customer in the design process in a very proactive way, so that consumers now become what we call prosumers. They can interact with companies in a very proactive way. And this has great advantages because now we can make what customers want, when they want it. And this enables companies to reduce waste due to overstocking or obsolescence. So this has great implications from a sustainability and circular economy perspective as well. Similarly, in manufacturing, because the foundational technologies that are used in Industry 4 can provide so much power in manufacturing that we can actually control quality. We can make sure there's very little breakdown in machines. We can make sure that standard operating procedures are followed without any disruption. And as a result of which, there will be less waste during production and recycled material can be used. Furthermore, a lot of the parts which were previously assembled can now be made as a single component using additive manufacturing approaches such as 3D printing. And so this leads to less parts, less movement of materials, and less assembly effort. Furthermore, the great advantage is that we can locate production facilities very close to consumers, thereby reducing a lot of the logistics effort. And this again will have a very big impact on the carbon footprint of a company because there is less transport involved. Similarly, we find that from a logistics perspective, we can make the flow of material more transparent, more easier to control, and we can again have the physical goods moving globally in a much more rational way. And this again can reduce the carbon footprint of the supply chain. From an inventory management point of view, because now we don't have so many components that need to be assembled together, the number of stock keeping units can actually come down. And furthermore, in additive manufacturing, many of the technologies that are used will lead to a completely different way of doing things, where we shift to inventory in the form of raw materials rather than semi-finished parts and components. And handling of these raw materials will not be that difficult. And this again brings down the amount of inventory that we need to have, thereby reducing holding costs and reducing costs to the company, while at the same time minimizing waste, further contributing to sustainability and a circular economy. Now, these are some of the advantages that I have talked about very quickly. There are many more, but these are just some of the more important ones. But what are the problems posed by Industry 4.0? Firstly, it is not just a question of buying new machines and investing in information technology infrastructure. We need completely new skills as well to actually make things happen in an Industry 4 setting. So we have to develop the skills, and we've got to hire those skills. And those skills don't come cheap because they are highly qualified people. And we need to develop those skills, and we need to pay more. At the same time, the managerial processes and the business processes within the company will also need to be modified and changed. And re-engineering these business processes is not something easy. It takes time, it needs effort, and again, it can be quite expensive in terms of resources needed to bring about the change. So high investment will be needed. But what is important is to remember that you don't need to actually put in all these investment right at the beginning. It can be done progressively, as I will mention towards the end of my presentation. Secondly, there is great concern about cybersecurity and intellectual property theft, because now everything will be connected to the internet. Cloud computing will increase. There will be great advantages in doing all that. But at the same time, precautions will have to be taken to produce the network from hacking and also preventing intellectual property theft. So investing in cybersecurity will also require new skills and a lot of resources. And the changes in the skill profiles, because although, as I mentioned, we'll require highly skilled labor, the number of the highly skilled labor will be much less. And what will happen is it will reduce the need for low skilled labor. So in economies where we have many people with low skills, moving into an Industry 4 setting could lead to loss of employment for low skilled labor. And this could be of great concern to governments. And furthermore, there could be industry disruption, because when an Industry 4 leading manufacturing firm moves into an Industry 4 setting, it is possible that some of the older companies, which are still operating very differently, may go out of business. So it is very important for governments to ensure that policies are put in place to reduce this disruption as much as possible and help companies that are behind to move forward and participate profitably with others who are moving into an Industry 4 setting. So these are some of the problems that can be posed by industry by transitioning to an Industry 4 setting. Now, what are the implications for emerging economies, having looked at what Industry 4.0 means? Now, in many developing countries and emerging economies, for many more years to come, it is possible that we will still have some companies which are at an Industry 2 level and also at an Industry 3 level. Not all the companies are going to move straight away into Industry 4.0. And this is true throughout the world, not just in emerging economies, even in many of the advanced countries, there will still be many companies that are operating at Industry 2 and Industry 3 levels. However, what is important is that in emerging economies, we should have at least many companies or as many companies as possible launching initiatives to transition to an Industry 4 setting. And as I've said, it does not mean that these companies need to go to the top of the ladder right away. It is not possible. Even in many advanced countries, there are companies which are not really at the top of the ladder in Industry 4. They are progressing. So we also need to start and move. We have to start progressing. So when I say that we should move to an Industry 4 setting, I'm not implying that companies should straight away get to the top of the ladder, which is really not feasible. You've got to keep building gradually. And one of the main reasons is that what we are finding today is that there are many firms in the richer countries which moved their manufacturing out to low-cost labor labor emerging economies in order to cut down costs and remain competitive. Now, what they are finding is that Industry 4.0 offers them the opportunity to reshow what they formerly offshored. So today there's a lot of talk about reshoring and nearshoring. Reshoring means bringing back to their own country what they offshored earlier. And nearshoring means bringing these closer to home. Because now you can achieve what was done earlier in low-cost labor countries with fewer people in their own nations. So the implication for many emerging economies is that relying on cheap labor to attract work from firms in richer nations may not work for long. I'm not saying that it is going to disappear immediately, but as firms in the more advanced countries start becoming very clever at using Industry 4.0, gradually we may find that the work that is offshored will start becoming less and less. So in such a situation, what do we do? The only option is for companies in emerging economies also to move into an Industry 4 setting so that they can become valuable partners to other companies which were previously offshoring work to them. So here's an example. What we are finding here, this is actually very recent. What we are finding here is that we have the vice president for footwear at you can see here Guillaume Meizank saying, about 10 years ago, it became apparent that the way we have been producing in Asia up to now would no longer be the unique solution in the long term, with large factories, thousands of workers, and that we would have to build up our own production in France. And then he goes on to say new material developments, new production methods. Instead of all that, just say Industry 4.0 will be making all this possible. And what we are seeing here is that company is now building what called the advanced shoe factory. They call it ASF 4.0 here. They are building that plant in a place called Ardois in France, where they have 4 digitally controlled intelligent shoe production lines. And by 2025, it will have a capacity of 500,000 pairs of sports shoes per year. Now, what they are saying is that this is going to be a very unique unique Industry 4.0 factory. Instead of 500 people, there will only be 50 working there to produce the same production volume, implying that earlier, maybe in another emerging economy, to produce that same quantity, you might have needed 500 people or more. But now you can do that with barely 1/10 of that workforce. So you can immediately see that the low labor cost advantage is going to disappear. And what they are pointing out is that thanks to 4.0 technology, we'll be able to produce different styles at the same time. Now, in the current production process, in the work that they have offshored to emerging economies, they produce a production line with one style and one color and produce in large volumes. Now, when they have perfected this technology, they can very quickly move from one to another without downtime. So this offers great advantages. Customization becomes much more feasible. So here he is sounding very ominous, where they are pointing out that the old way of working is not going to be useful anymore. However, I'm sure that many of you, especially in business in Sri Lanka, would have read about all these. So it's not as if I'm saying something new. I'm sure you're aware of all these examples. One of the earliest companies was Adidas that got into Industry 4.0. And during 2016, 2017, they set up what they call their speed factories. And their plan was to actually bring back all the production that they have offshored to Germany and the USA and to other countries there. Now, after a couple of years, they have decided against that. And there are many glitches that they are facing with using Industry 4.0 for some of the products. But what they have now done is they have said that what we are now going to do is we are going to go back and work with our suppliers in selected countries like China. And we are going to use these advanced technologies in those settings. And the reason is they say that there are suppliers in China. They have skilled labor, meaning labor who can work in an Industry 4 setting, and yet they are lower cost when compared to the labor back in Germany. And these companies have also got excellent manufacturing capacity, meaning they have already started progressing to Industry 4.0. So they say that while we are ironing out all those problems of bringing back everything to Germany, we are still going to work with some of the leading Asian manufacturers who have the skills to move into an Industry 4 setting. So the lesson for us is this, that if we have manufacturing capacity in our countries where we have started progressing into an Industry 4 setting, we will still be able to work with many of the companies that were previously offshored work to us. And we can still become very effective partners. And by working with them, as we learn more and more, we ourselves could become independently leaders in Industry 4.0 manufacturing. So I think it is the right time for us to make this change, start preparing ourselves to move into an Industry 4 setting. So having said that, the next question is, how would I assess whether my company is ready to move into an Industry 4 setting? What kind of expertise, what kind of skills should we have, and where are we? So in order to answer this question, what we did is, actually this whole work started because of some work that I undertook for a Japanese think tank called the Economic Research Institute for ASEAN and East Asia. So I've been working with this think tank for many years, and they asked me whether I could develop a simple framework which can be used by management, not very technical, not a lot of engineering, and not very mathematical and statistical, something like a quick reckoner. I use the term I use the word self-diagnostic tool. So this was something that was a very challenging exercise. So we tried to do some work on that. And my good colleague, Dr. Prem, and we have been working on this for quite a while. And as part of this work, what I did was I looked at the literature that had come out in refereed academic journals, but I also looked at the work done by leading consulting companies throughout the world. And I also looked at industry reports that had been put out by various governments which were promoting Industry 4.0. And then using all those ideas, I built this readiness assessment framework or model, whatever we want to call it. So I don't claim any originality. The only value that I added was that I was able to look at the work done by many others and then select the good ideas from all the different pieces of work. Then I just put them together. So creating this eclectic framework was the only contribution that I made, but I actually rode on the shoulders of others who had done a lot of good work. So after I went through all the literature, what I found was that if you really want to do a self-diagnosis, you need, any firm needs to look at 8 main determinants. Now, I don't claim that this is the best way to look at it. I'm sure we can do it in many other ways, but this is one possible approach. And these 8 determinants are strategy and organization, plant and equipment, managing operations, supply chain management, managing operations quality management, managing operations with respect to energy, then product definition, human resources, information technology systems, and data management. So what essentially I'm implying is that we have to look at these 3 determinants in our company to find out where we stand with respect to each of these when compared to companies that have already made significant progress in moving to an Industry 4 setting. So in order to do that, we created a little diagnostic framework, which I will now share, and then I'll come back to the slides again in a minute. So can you see this document, Prem? Can you see it?
I can see.
Yeah, I can see. Thank you.
Yeah, thank you. Now, let me just explain very quickly one of the determinants, the strategy and organization. Now here, if you look at this, based on the work done by many others, and you see here, this determinant has several assessment criteria. One criteria is extent of Industry 4 emphasis in strategy formulation and implementation. Then we have inter-firm collaboration. Then the allocation of funds for Industry 4. Then measuring the impact of Industry 4 implementation, leadership, innovation orientation. So it has several criteria or elements within the one determinant of strategy. So for example, suppose we take leadership. We have to ask ourselves in our company, what is the attitude of leadership towards Industry 4.0? Top management does not recognize the value of Industry 4 and adopts a business as usual attitude. That's the lowest level. The next one is the leadership is making preliminary investigations into the feasibility of adopting Industry 4 and the benefits to be gained. At the very high end is there is enterprise-wide support for Industry 4.0. A culture of sharing lessons learned and disseminating the knowledge gained is prevalent within the company. So what we do is when we look at strategy and organization, we assess it with respect to each of these criteria. Extent of Industry 4 emphasis in strategy formulation, inter-firm collaboration, allocating funds, critical allocation of funds, which means top management has allocated funds specifically to help the organization to transition to an Industry 4 setting. Then measuring how well we are implementing Industry 4, leadership, innovation, orientation. Similarly, the second determinant for plant and equipment, we have some criteria here for each of these. Then the third determinant is information technology and systems, and we have several criteria for these. Now, I will talk about how you can get access to all of these when I come to the end of my presentation. So the fourth determinant is human resources. We have some criteria for those. Then we have fifth determinant is product definition. This is especially when a company is designing products. Then managing operations, energy consumption management, managing quality, then supply chain management. So for each of these, we have several criteria. And we can use these to rate ourselves. So now I'll move back to my slides. So these are the 8 determinants, and for each determinant, we have many criteria. So these are the 8 determinants that I talked about. And each of these determinants consists of several elements or criteria which will determine the Industry 4 readiness level with respect to each determinant. Now, all of these can be made available to whoever is interested through FCC ISL, and you can contact Mr. Kirti Gunawardana to see how you can gain access. And at the end, I will also explain one approach that we have in mind. Now I'm going to illustrate this rating using the example of plant and equipment. Now let us say as determinant 2 plant and equipment. Suppose there is a company where we are carrying out this readiness assessment. Now, to carry out this readiness assessment, the best approach is to have a cross-functional group of managers and technical people within the company who are well-versed in the way the company runs. So it is always good to have a group of people working together rather than one person trying to do the evaluation. So let us say there is a company where they are carrying out this assessment, plant and equipment readiness for Industry 4. The machines that we have are not suitable for an Industry 4 model. We need money to overhaul, to move to overhaul the machines, meaning we might have to sort of add on a lot of other equipment around the existing machines, programmable logic controllers, add new sensors, many other things to actually use the existing machines. Some machines that we have may be newer generation where the amount of modification needed may be not that much. And then most of the plant and equipment meet Industry 4.0 requirements, and plant and equipment meet Industry 4.0 requirements, meaning a machine can talk to another machine, machine to machine. And we call that M2M. So let us say that the group decided that we are in level 2. Similarly, the machine and machine system infrastructure, machines and systems cannot be controlled through IT, then we are at level 0. Some machines can be controlled through IT, but there is no machine-to-machine connectivity. Some machines can be controlled through IT and have M2M capability. All machinery can be controlled through IT, and they have full M2M capability. So let us say here again, we are at this stage. Then let us say whether we have autonomously guided workpieces. Now, there are no autonomously guided workpieces in use. They are not in use, but we think that we can use it, and we are developing a business case to introduce those. Some are being piloted, and here they are widely adopted. So here again, let us say we are at level 2. Then maintenance of plant and equipment, let us say we are only doing breakdown maintenance. And at the very high end, we have total productive maintenance, which is fully linked to the cyber physical production system. So here, let us say, this company says we are in level 1. So here we are in level 2, 2, 2, and here we are in level 1. So now, just to get started, we use a very simple scoring scheme where if you are in level 0, you give a score of 0. If you are in 1, 1, 2, 3, 4. Now remember, now this is not an academic exercise which is going to be tested statistically and all that. This is for a group of managers to carry out a good self-diagnosis in a very simple and easy way. So the academics in the group may think that, there would be much better ways to do it. Yes, we agree, and we also, Dr. Prem and I have discussed that there are many ways. Structural equation modeling, there are so many analytical hierarchy processes, and we have used some of these as well in some other studies, but here we want to keep it simple. So we just give these simple scores because the idea is to find out where we are. So here we are given, for the first 3, we are in level 2, and the last one, we are in level 1. So here we are in level 2, 2, 2, and 1. So here we give the scores 2, 2, 2, 1, and the total is 7. So what we do is, suppose we take this 7 and maybe we divide that by 4. So we'll get an average value. There are many ways we can do it, but one possibility is to divide it by 4 and get an average value to see where we stand with respect to plant and equipment readiness. We can do the same thing for all the 8 determinants. So here's an example, and Dr. Prem is going to talk about this in the case study as well. So in one company where this study was done, these were the ratings given by the managers. In fact, Dr. Prem and I worked with them, and Prem spent a lot of time in that company in what we call an action research approach, where Prem guided them, and we did a lot of these, got these values. So here are the overall scores. Now remember, for plant and equipment, we got 7. So here are the average values that we got for all of these. Remember, if you're right at the top, your average score would be 4. But now we have these average values. Now this can be shown in a kind of a little diagram like this. We can call it a ray diagram or anything, but I like to call it a web diagram, because as we saw earlier, the linear snake supply chain has now been replaced by the spider. So I like to call it the web diagram of the readiness score here. So here is that. So now you know that with respect to managing quality, you are behind here by so much. So like that, we can decide how much behind we are with respect to each of these determinants. So now we know that in certain areas, we are really very, very poor. For example, this company, with respect to plant and equipment, they had 1.75. Managing the supply chain, they are 0.8, way behind. In some areas, they are a little bit forward, like for example, strategy and organization. There is a lot of commitment in the company. The IT systems are pretty good, but we need to move more. So by looking at this kind of a little diagram, the management team can now debate and ask, what do we do now? How do we proceed from here? So that is what I'll move on to next. Now here, there are maximum score that you can get will be 132, because there are 33 elements in the 8 determinants. If you add all the elements or criteria there will be 33. So the maximum you will get is 132. So what we did is, just to give us a rough idea, we divided that into 4 groups. So if you're from 0 to 33, you're a hesitator, meaning you're there, you know, but you're still hesitating. You're not moved forward. If you're between 34 to 66, you have realized the potential of Industry 4 and you have started taking your baby steps. You have started moving with enthusiasm. If you are between 67 to 99, you have passed that baby stage. Now you're an adult and you're really growing up fast. And then 100 to 133, you're an expert already and you're right at the top. So for this particular company where we did the study, the total is 52. So we can say that this particular company in this example is a potentialist. Okay, now what are we going to do? We're coming to the end of the presentation. So how can we use the findings of this readiness assessment model? Firstly, you have to do this honestly, and you shouldn't deceive yourself. If you're really behind in something, the management team must say, yes, we are behind. For example, if in IT, we have to do more things, the manager heading the IT team should not feel bad to say that we are behind. It is nothing personal. It is for the organization. So wherever we are backward, we should say, yes, we have to move forward. We have not done enough. So it is not a question of blaming anyone or to say your department is better than mine. That is not the idea. If that approach if that kind of mindset comes in, then it is not going to work. So in the case study company where Dr. Prem and I did some work, what was really amazing to us is we found that it was a very collegial culture there. And they were really very keen and they were willing to move forward. And so this augurs well for that company and we are sure they'll be successful. This was also tested in 2 other companies in the ASEAN region. We tested this in a leading automotive firm in Thailand, and the management there found it extremely useful. But this company is a subsidiary of a leading Japanese company. So the managers there said, we have sent all these information based on this assessment to our headquarters, but the actual strategic interventions will depend on whether they give us the go-ahead and what to do. So they were very happy with what they did, because they felt that they now are able to have a good dialogue with their headquarters in order to see where they need to improve. We also did this study in an integrated textile plant in Indonesia. And the senior managers from there attended a workshop which we conducted in Bangkok. And they were also very excited about this and felt that now this is a good way for us to ask top management to give us funds to move forward. So it all depends on how you do this readiness assessment. It is a self-diagnostic tool which tells you how we can move forward. So the next question is, we can use the outcomes to define a vision for the short term and the longer term. Now, the reason why we say that is, you can't straight away jump from where you are now to the best in the world. It takes time, but we can start moving progressively. How do we do that? So that's the vision management has to create now. They must say, okay, we want to move forward. We want to transition to an Industry 4 setting. So these are the things that we are going to do within the next 2 years. And then after that, this is what we are going to do. And then this. So you need to have for the short term and the longer term. In a few minutes, I will talk about the implementation schema, a possible approach that we can take. Now, what you might find is some of these things you can't do all by yourself. You need to partner with some of your supply chain partners. For example, if you want to improve the product design, you might have to work with a supply chain partner. If you want to have newer machines, you might need to work with, or you want to upgrade your existing machines and add some intelligence to those, you might have to work with an engineering partner from outside. So you need to identify partnerships with various entities to implement your programs. So you got to work on that. Trying to do everything by yourself may not be feasible. What is important is, while all this is going on, you must have a steering committee headed by a senior influential manager whose job would be to see that whatever we have planned is getting done. Because if you do not make someone accountable, then it becomes nobody's business. Everybody will say, oh, I thought you were going to do it. So the steering committee should have a senior influential manager. I use the term influential because the senior manager must have the ears of top management and must be able to get the necessary support. So whatever you have planned in the short term and the longer term should proceed according to the plan. And this senior influential manager is heading the steering committee, must make sure everything proceeds according to plan. So it becomes like a huge project management exercise. While doing all this, we also need to build internal capabilities within the company, skill development, upgrading our maintenance capabilities, developing skills in quality management, skills in energy conservation. So there'll be a whole lot of skills development that needs to be carried out. We have to invest money for all of those. Then as we move forward, when we first start, we may make some mistakes. So the steering committee will evaluate what we did right and where we made mistakes. And then we learn from these and we do not make those mistakes again. So our step six evaluate outcomes, identify issues, what we did well, what we did not do well, and then go for continuous improvement. So we should develop what is popularly known as a Kaizen mentality, continuous improvement mentality, when we are implementing this. Now, I talked about the using the implementation schema. Now, this is a little diagram that I want to show you. It might look very confusing, but it's actually a very simple diagram. What we are saying is that we can divide the transition to an Industry 4 setting in 3 stages. And this is the light green, and this is the medium green, and this is darker green. The complexity increases as we go from lighter to darker. So here in stage 1, we can, on the left-hand side here, we see some important boxes here. What we call manufacturing, products, IT deployment, supply chain, essential enablers. So let us take stage 1 in manufacturing. What can we do? What this schema was developed based on a study by Frank and others in Brazil. They did a study of companies in Brazil that had implemented Industry 4. So what they found is that many of the companies started doing this first. They realized that they had to improve their manufacturing decision making. So they strengthened their ERP systems, their manufacturing execution systems, SCADA. They started using sensors, actuators, programmable logic controllers. Then they started improving their energy consumption management, quality enhancement, product customization. And then they also started traceability. You can use RFID, you can use many things to trace their products and materials. And while doing this, if your company is also designing products, you start designing passive smart products, meaning that the product simply has intelligence built into it for connectivity, monitoring, and controlling. Say, for example, if you have a color printer and a good color printer today, it will tell you when you are running out of toner, and it will even tell you what kind of color toner is now needed. So those are like simple intelligence built into it. It's passive monitoring and control. But you move progressively to enhance smartness in the products for optimization, and the product itself can become autonomous. Similarly, data collection. Initially, you are just collecting data for remote monitoring, then for remote operations and machine-to-machine capability, then fuller machine-to-machine capability. So you progress this way. Similarly, in your supply chain, first, within the company itself, in your company, you start a good information flow visibility approach, then work with your suppliers, then work with your customers, so that eventually your entire supply chain is integrated with respect to information flow. Then while you're doing this, there are 2 essential enablers: continuous skill development as you go this way, and cloud use, and you're using the cloud first, then secure and advanced interconnectivity. When you're actually linking up with your suppliers and customers, start using big data and analytics to generate information to keep improving the way you work. So you can start off in a very simple way here in this area. So you can develop programs, you can start an initial program with little projects to start all of these, and then keep moving. So these slides will be can be made available to you through Mr. Kirti Gunawardana, and you can take a look at it. Again, remember these are just suggestions. You can improve on this. This is just to get you started. We are not claiming that this is the best way to do it, but this is a start. So what the lessons that was learned in the Brazilian exercise was that having a good integrated IT system within the company is an essential prerequisite. So that even when you go for machine-to-machine connectivity and so on, information flow must be good. And without that access to information, you can't make good evidence-based decisions. Secondly, when you start using sensors, actuators, PLCs, trying to gather data at the shop floor, then you can use your SCADA, the supervisory control and data acquisition system for production control, diagnosis, your manufacturing execution system, and your ERP system can help you to make better manufacturing decisions. Then users' use of sensors and related technology can promote energy conservation, quality improvement, and so on. So what these companies did is they started off with all of these, which don't cost that much, but are still feasible, and these can bring about immediate improvement. And when you bring about this improvement, you will save money. Now that money can then be put back for further work. Rather than just taking off those profits, those savings can then be used to invest to move further ahead in your Industry 4 progression. Another thing that they found is that large companies do this much faster than smaller companies. This is obvious. The reason is the resource availability for larger companies is much greater, skills and funds. So this is where government initiatives are needed. Can we develop policies at the national level? And policies alone are not enough, because policies are just statements. The policies have to be implemented through policy instruments. And then again, we need institutional support where training, advice, consulting services, all these can be provided. So at the national level, we need to think of good policy instruments like low-cost loans or tax benefits to smaller companies that want to move into an Industry 4 setting. Now, there are many things that we can discuss there, but we need some actions at the national level to get this whole thing going. So that is where FCC, ISL, and SLIIT and agencies, other agencies should actually talk to government and get them to act on it. What is also important is we should not try to reinvent the wheel. We can learn from our ASEAN neighbors, such as Singapore, Thailand, and Malaysia. I'm not including India, China, and all that, because those are huge countries which have very different structures. Whereas these countries are smaller and they are like us. So we can learn from their experience, and they have made good progress in Industry 4.0. And my dear friend and esteemed colleague, Dr. Prem will talk about a good case study that he was instrumental in initiating in Thailand, in the ASEAN region, in order to illustrate this framework through a case study. Now, before concluding, I just want to show an example in Thailand, where we see here, this is not strictly manufacturing, because many of the manufacturing firms don't like us to share their details, but this appeared in the public domain in a journal article, so I thought I will use it. Now, this is an example of a company in Thailand, located in the province of Nakhon Nayok, where a company which was manufacturing vegetables and fruits, it's a food processing company. They are doing it organically, so it's part of a manufacturing enterprise, food processing. This is the growing part. So here they are growing organic vegetables and fruit processing. So they decided to move into an Industry 4 setting. That is the advantage. So here this diagram shows that they are using artificial lighting technology to cultivate fresh organic vegetables and fruits for processing rather than relying only on the weather. So here are some of the equipment and environmental sensors that they used. For example, they used a lot of technology here for the lighting, for the carbon dioxide supply, sensors for environmental control, light, air, water, temperature, carbon dioxide, and then communication and management. They had a very sophisticated IT system in place. Even for applying nutrients, they used, through the use of sensors and programmable logic controllers, they had developed automated systems. And this is also taken from the diagram, from the journal article, giving this example where you see here the various Industry 4 technologies that they used to carry out their analysis. Now, when you get these the slides, copy of these slides, you can take a look at all those or go back to the original article. Now, what I really want to show you is this, the cost. The infrastructure cost. This is in millions of baht. It's about 5 to 6 million baht. But if you want to produce the same amount of vegetables and fruits using traditional organic cultivation, it's going to cost you 10 to 12 million baht. The fertilizer cost here was only 10,000, whereas if you use the traditional cultivation, 50,000. The unit cost is 4.25, here it is 6. The harvesting time here is 21 to 30 days, there it's 45 to 50. And the weight per unit in grams is 100 to 175, here 75 to 100. The crops per year they were able to get with the Industry 4.0 factory here is 12 to 15 crops per year. Otherwise, traditional cultivation, 4 to 8 crops. And when you look at this, you will find here that it was very, very profitable for them to do this. So while there may be costs, you could very well find that there are benefits also to be gained. So that is just a simple example. I wish I could have shown you some manufacturing examples, but as I said, a lot of the companies are very guarded. They don't want to talk about it. So I think it is not fair for me to talk about this. So to conclude, what I want to point out is that with the Federation of Chambers of Commerce and Industry, the Faculty of Engineering of SLIIT and our school at the Western Sydney University, we have decided that we will continue with this collaborative research called Transitioning Sri Lanka Manufacturing to an Industry 4 setting for a longer period of time. So we are going to do this in phases. So today's webinar is the first activity in this project. Now our idea here is to provide preliminary insights to participants to use a readiness assessment framework. This is it's a very simple tool. It's a self-diagnostic tool. You don't have to share this knowledge with anyone. You don't have any consultant coming in and trying to tell you what to do, or you can do it yourself. What we are going to do is to help you. We are going to put this up on as an online self-assessment tool so that you don't need to actually do it. You can go online and then do it. There will be no confidential or classified information that you have to divulge. So you can feel perfectly safe going online. Now, suppose there are 100 companies that do this. Then we will have the information of 100 companies online. And for what we can do is for each company, we will know the scores on those 8 determinants. Now, suppose we have 100 companies doing this, then it will become possible for us to prepare a summary without telling which company is what. where we can say that this is the kind of average values for each of the determinants out of the entire companies that did the survey. This is the maximum, this is the minimum, this is the mean value, this is the modal value. And then you can then find out where you stand on that spectrum. Now that is going to be very helpful to you, because if you can then decide what you need to do to move forward, because if there are other companies that have moved forward in some areas, then you know you also need to move forward. Now, this kind of exercise is done in many parts of the world. For example, Canada is very good at this. And all the information is confidential, anonymous, nobody knows who is what, but the industry itself benefits by knowing where they are with respect to the others in the business, in the industry. So we plan to do this. And if you do this and participate in this exercise, we can provide you with the summary. And what we have also decided is that once a company does this, Mr. Kirti Gunawardena will be our focal point in Sri Lanka. If you want to work with us further on this, we will be always glad to help. And we would be happy to work with you. Or alternatively, you are completely free to work on your own. And later on, if you could share your success stories with us, that will be lovely, because then we can use that in teaching and in also encouraging other companies to move forward. So that brings me to the end of the presentation. There are a couple of the references I have put here, which I have used in the PowerPoint presentation. So you can go to the original work if you wish to. It's very useful. Now, at the beginning, I just made an acknowledgement in very general, but now I would like to thank all the participants for listening to me so patiently. And I'm very grateful for your presence. It's so encouraging to see so many of you here. Now, I would be failing in my duty if I do not express my sincere gratitude for the support, guidance, assistance, and encouragement provided to me, firstly by the FCC ISL, and very grateful to the President, and especially to Mr. Kirti Gunawardena, who has been a remarkable guide for me and helping me to prepare this presentation, telling me what would be appreciated. And I'm very, very grateful to Mr. Kirti Gunawardena for providing leadership to this initiative. Thank you so much indeed. To our Dean, Professor Amir Mahmood, who has been always a great supporter. And when Prem and I told him that we want to work on this, he said, just tell me, let me know what you need and I'll be there to help you. He's been a great source of encouragement for us. So thank you, Professor Amir. He had to go away for a meeting. So he has expressed his apologies. He has a meeting with the Vice Chancellor. I would like to express my sincere thanks to the Professor Chandana Pereira from the SLIIT for participating in several consultative meetings when we were preparing this for this workshop, for this webinar. So thank you, Chandana, for your guidance, your support, and your friendship. To my two dear colleagues, Engineer Sena Piris and Engineer Nihal Kure, they were my batchmates at Peradeniya. And we are friends now for more than 52 years. It's a long friendship, going back to more than half a century. And starting right from my university days till today, I have learned so much from both of them. And Sena and Nihal, thank you so much for all your friendship and your support and your guidance. And last but not the least, to my dear colleague, Dr. Prem Samarnayaka. Thank you, Prem, for all your hard work and all your support, and for acting as a sounding board. I'm truly grateful, and I value your inputs very much. So thank you again, ladies and gentlemen, and wish you all the very best in life. Thank you so much.
Thank you, Dr. Ramanathan, your fantastic, insightful presentation with your case study, a lot of informative information. I think you have done my job also by concluding everything, summarizing. I don't have anything to do. I just would like to say here, now these days you would have seen, seen some of these TV interviews, Dr. Harsha De Silva, previous minister, who was telling us many times, Apple iPhone is produced, they are spares produced in 43 countries. So we could not get anything out of that. So as Dr. Ramanathan also mentioned, so we as a country, we say we are very good in communication, we are very good in IT, we have so many IT universities, we are very good in engineering. Technically, I have to agree with him that we also should get something out of that kind of an initiative. I think what we are lacking is something in the industry for, or rather our industries coming at least closer to this area is very, very essential. So I will not, do any kind of summarizing there, since Dr. Ramanathan did all that. So let me introduce Dr. Premaratna Samaranayaka. He's a senior lecturer at Western Sydney University, Australia. His areas of expertise including supply chain management, production planning, business process management, and enterprise resource planning. He's actively engaged in research collaboration with industry and has completed several research projects in recent times, including a research project on assembly, maintenance planning, control, and execution using SAP ERP system and many other research projects. His educational qualifications include a PhD from University of Melbourne, Mechanical Engineering BSc, First Class Honours, the Postgraduate Diploma in Computer Science. He completed SAP certification on best practice in ERP, and is a certified solution consultant of SAP ERP for small and mid-sized enterprises. Let me invite Dr. Premaratna Samaranayaka, popularly known as Prem, to share his real life experience and a case study, Industry 4.0 Readiness Assessment. Prem,
thank you. Thank you very much, Mr. Kirti Gunawardana. And this is a great privilege to be with all of my Sri Lankan fellow Sri Lankans. And I do not take it lightly, and this is a great opportunity. And I like to start, of course, thanking many, but again, it takes time. So probably I'll echo Dr. Rama's thanking at the end, and then I'll start my presentation. And like to make it shorter, and Dr. Rama touched on some of the things that I will also have, so that I can make it shorter in my case study presentation. So I'm going to share my screen, and I'd like to ask whether you can.
You can share.
Okay, now can you see my screen?
Yes, can.
Yes.
Okay, I'm going to go to the presentation mode. Okay, so can you still see my screen with the presentation mode?
Yes, good.
Yes.
Okay. Now, thank you very much. And again, this is a case study that I'm going to go through, and the findings of a case study that we did together, of course, Dr. Rama and myself, in one of the companies in the Asian region. And this was very much a coincidence that when we had our industry for readiness assessment workshop, we were able to get this company involved. And also the coincidence that they were also doing the initial work. And now if I go straight into the company's background, and again, there are a lot we can talk about this company. and it's a very large manufacturing, glass manufacturing company, and produces many standard products, and they also have number of plants in the whole country. Now, if you look at the glass manufacturing, of course, this is a very, very typical and traditional manufacturing kind of thing, where they have got number of manufacturing processes starting from these material preparations to the packaging. And one of the very key part of this process that we looked at was quality inspection, where we visited this factory and then we saw how they do things and what they are really motivated to do this industry for. Now, the manufacturing process is very energy intense, as you can imagine. Glass manufacturing, I know that in Sri Lanka also there are a couple of glass manufacturing, as I know at the long time, but maybe not, maybe many now. And again, the energy intense manufacturing has got this very much the quality as one major area. So what they were looking at as part of their improvements or to get into this industry for reducing material waste. And there are two sides to that, where they can reduce the waste and also they can improve the quality. At the same time, they were looking at energy consumption. As you can imagine, this is a very energy intense manufacturing. Now, with the company background, is very much the coincidence that there was an early stage of looking at how they can go into advanced manufacturing or industry 4. And now what I'm showing you now is the company's approach, where they had these 3 building blocks. Now, the first one, if you see the assessment, that is where they had these 2 very fundamental questions. I think by this time, Dr. Rama has already explained how you can go and get the answer to that question or those 2 questions by having the self-assessment. But for them, it was just the questions to start with some ideas of 5 areas they want to look at. From the very start, you can see this pyramid where they don't want to go very much to the top, but they wanted to start with this spontaneous thing, like what exactly they can do immediately, sort of thing. And then moving from the spontaneous to the processes and methods they are using. And this is where they looked at, okay, they were looking at the administrative areas of the complete manufacturing and the tools supported. And the top, they were only looking at the integration as one of the main thing at the end of this exercise. They were thinking very much in a big way of getting the integration. When you look at the integration, there are many ways people can look at the integration. Now, the process integration, technology integration, and and also the data integration. Now, that's their main questions. It was very much the initial stage. And then they wanted to see how they can answer this question, where should start? Because as Dr. Rama said, you may have got so many different areas that you want to work, but you need to find where we should start. But for them, it was again very interesting. They came up with this plan from the pain points to the plan and target. And you can see in the middle, right in the middle, what they have is prioritization. Now, what you looked at, if you see Dr. Rama's framework, it very clearly has identified, of course, as we said many times, that's not the best approach, but one of the approaches that you can use. But by doing the analysis or the self-assessment, you can see different determinants at different levels using number of criteria that would help to get to that prioritization. Exactly, that's where they looked at, oh, this is the framework they can use. So they had this idea of going from pain points to plan and target through the very important part of this prioritization. And then around that, they also looked at the possible projects and expectations of actual. They are all interrelated. Now, for a very particular reason, they did not have follow-up, because this is the very early stage what they were looking at, how they can answer these two questions and the subsequent question, but they were not aware of what kind of follow-up actions. That is very understandable. Why? Unless you have got the project, and depending on the project, your follow-up could be different. As Dr. Rama said in that second last slide, there are 8 steps where you can go and then do this stepwise approach. So for that purpose, they did not have, because of the initial stage, they did not have the follow-up action. Now, if you see again, they have translated that kind of approach into a Industry 4 assessment frame implementation plan. So very much what I want to highlight or emphasize here, they had the vision, and to call them, because we call the top gas as the company name, they want to go from the current manufacturing to top glass 4.0. But I'm not going to go through all of these steps or the questions. And very importantly, I like to emphasize the first assessment and the first question, understand the current situation. Immediately when they see there is a framework that they can use to understand the current situation, they came on board and looked at how they can go into the next stage of transformation action plan and evaluate the first round and review results. So if you look at this approach, pretty much this is similar to what Dr. Rama said at the very towards the end. By using the assessment, you can have action plan, and of course for each and every project you can have a kickoff, execution and review. So they had this plan, but what really they used the framework that we developed, Dr. Rama developed, as the initial point. Now you can see with that approach, the company involvement and approach, they participated very actively in the workshop that we run, and then they did the self-assessment of Industry 4 readiness using the framework. And for both of these, there was many senior managers involved. Now, after they did the self-assessment, they also came on board to continue the second stage, where we had the further discussion on the preliminary findings from the self-assessment, and also exploring possible approaches in moving towards an Industry 4 setting through follow-up projects and programs. And as Dr. Rama said, it could be a number of projects, it could be a number of projects in a program. So for them, what they set the initial project called the Digital Transformation Project. And again, they had the kind of understanding of their current position, and they went into the this particular project, and then they had the kind of they knew where they want to go because they knew where they are, and they have gone through that self-assessment. Now, Dr. Rama already put this slide, and I'm just going to emphasize, if you look at their self-assessment, yes, and you can see each and every determinant has got number of criteria, and each criteria, the most important thing, each criteria has got number of levels. I call it the progressive, where they can see the transition from the very low level to the top level at the Industry 4 setting. So it's also not a uniform thing. We don't have always equal number of criteria. It's all very much based on what really they need to assess. So for some determinants, yes, there are 6 criteria. So we have seen these numbers, but the numbers very important to take them in their context. What context we need to look at? How we look at each and every determinant from the perspective of their importance. We call it, there are 2 things that they looked at how important each one of these determinants, not just based on the level they are, but also how they are interdependent. That's something we are currently working on, setting interdependencies of these determinants for individual different sectors or the manufacturing industries of the manufacturing sector. So you can see, as Dr. Ram also touched on this is at the highest level, 2.67 on average out of 4, whereas the product definition is the lowest. So it is not just the number, but they had these numbers as a guide, but also they had the levels of each criterion as the basis to move forward and to prioritize these things. So if you remember the first slide about their plan, prioritization is one of the very key aspects. So what they did then, they went to this each and every area and looked at how they can do the further work. Now, before I go to that work, of course, Dr. Ram also mentioned this, they are in this range in terms of their self-assessment. So they are very much not at the very bottom, but also not at the top. But they are very much valuing the framework to understand the current situation. That's the most important thing. They really like the framework to see where they are. That was their first question. Now, if you look at, in fact, in the second stage, what we did, we had some questions to validate their self-assessment and also to see what approaches they can take moving forward. I'm only summarizing some of their statements under each and every determinant. You can see under the top management support, they were very much in both cases, in the self-assessment and in the interviews, they said, yes, top management full support, 100% budget and commitment. That was something you can see with many technology transfer ERP implementation. The top management support is one of the very common critical success factors. So there is no difference here. But we are saying there's no rocket science, but they were very happy that they have that support, and then they can see the rest is easy. If you look at the importance and current status of plant and equipment, the total productive maintenance is only 50%. And you can see that rating very much is aligned with this. And aim is to have automated response between machines. And you can see by having the machine-to-machine interface, not only can do the communication, but also can have the big data, and by having the big data collection also can lead to the data analytics. And I'll come to that in a minute later on by their plan. Then currently, condition-based maintenance, they are not into the total productive maintenance, but they are really aiming to go towards that using this machine-to-machine connection and the big data. And when you go to the next ICT and data management, see, they have established a separate team called data team. This is the important thing that many organizations, you may remember, early or late 90s, before 2000, there was a huge demand for this ERP implementation. Then some organizations may have not even had a separate project management or IT teams. So for this, in fact, they established data team. You can see the data engineer, data scientist, and data analyst. And also the data team is a new team as part of the digitalization program. So they said we aim to integrate them into one system. You can see, I purposely put this, they are aiming to use this SAP Analytics Cloud. So I recently went through the training as a trainer, and there is so much potential. I know SAP solutions are very expensive, but they can run this on top of their standard ERP by collecting a lot of data. So the idea is that they know where they are, and they also know where they want to go in terms of each one of these determinants. So if I go to the next one, human resources, this is the top priority. Why? Because they are not doing well in terms of the skills. Need to develop business analytics skills in the workplace, because they are talking about a lot of requirement for having that data analytics skills in the workforce. Then it comes to the worst rank determinant, the product definition, and they are really looking at how they can go from current product development process into the new product developments, even having the bottle idea as a smart product. I think we all know the smart products. The smart products always let the owner knows what to do in terms of the maintenance or in terms of replacing things and all that. So this is where they are very much focusing now, but also they are looking at the energy consumption. Energy advanced process control. They are having the project 3 in current program is aimed at reducing energy. As you can imagine, in the glass manufacturing, that takes a lot of energy. And some products are also in improvement stage without compromising the quality. You can see they are doing it in parallel. By reducing the energy consumption also can lead to improved quality. And there are a number of examples. Again, not the time to talk all of that, but you can see that these determinants are interconnected. Now, if I go to the last two determinants, you can see the furnace advanced process control. They put that as part of improvement in the this area, quality management. And then finally, also they had supply chain management. This is where they looked at that product definition, engaging with the customer and supplier, both for the raw materials and the final product, how they can get the both product definition and supply chain management, which are very low rank, as the combined thing. So this is where they are not only using the ranking, but also they are using the interdependencies of these determinants by way of putting strategies to guide their approaches for the improvement. So if you look at for each product under the digitalization program, the company will have the customer as a partner to collaborate. It is not new, but they haven't had that. So, but with this program, yes, for new products, collaborate with potential customers. And other consideration when keeping inventory are stock keeping unit value of the product. And Dr. Rama touched on that under the inventory management, and shorter lead time, including procurement lead time for raw materials. So they are looking at all of these measures as part of improving. As we all know, if you don't measure, you can't improve. So that's very much the thing that they are following. And if I come to the kind of very brief statement on findings and conclusion, this is by their words. The company emphasized the usefulness of self-assessment of Industry 4 readiness as critical element of Industry 4 implementation adoption. Why? Because they had the first question to understand the current position. So they value this as the critical part of their journey. Company not only assessed the current status across each determinant, but also identified, prioritized key areas for the first phase of Industry 4 implementation. So we call it digital transformation using criteria and levels used in, they are not talking just the numbers, but they are using each and every criteria and the levels they are at. Top management support, I think it is very much, we have said a few times, identified as the highest rank determinant. And that was a bonus, because unless you have that support, both the budget and the commitment may not work and may not be possible to do the Industry 4 projects. So the company identified priority areas based on the self-assessment, interdependencies of closely linked determinants. I already mentioned those things: plant and equipment, and the energy consumption management, quality management. They are the three determinants, but they are all closely linked. In the case of this glass manufacturing, they are doing the manual inspection for the quality inspection in the plant, and definitely they have to have a better equipment so that they can get the quality inspection. I know that with the very high temperature that they are running, they are also looking at the infrared cameras where they can see the temperature profiles and all that. The strategy to combine, this is the other thing. They did not only use the determinants, but also they use the combination of determinants. The strategy to combine both product definition and SCM, I already mentioned, in Industry 4 implementation could significantly improve the overall Industry 4 maturity. Meaning you are trying to improve two determinants, but by combining these two can improve not by the sum of individual, but much more than the sum of individuals. So that's something they realize by having the combination of these two determinants. So pretty much that's all I have to say, and thank you all. And I'll echo all of, I'd like to thank you all, and including three organizations, of course, our very much the leader or the leading role that Mr. Kirti Gunawardena played, and so much hard work, and our partners from SLIP, and also Dr. Rama, who has been my mentor, and I know him for how many years? I think Dr. Rama said he knows two of his batchmates for 52, and I know Dr. Rama for now 23 years. So I just 1988 at AIT. So thank you all. And we can come back to questions and answers at the time it is set for this session. Thank you, Kirti, and all.
Thank you, Dr. Prem, for a nice presentation with your experience in different locations. Thank you. That's very insightful for our participants. So we're little behind the schedule, almost, I can't say little, quite. So let me introduce the next speaker, Senior Professor Chandana Perera. Chandana Perera is a senior professor in the Department of Mechanical Engineering, Sri Lanka Institute of Information Technology, known as SLIT. Prior to joining SLIT, he was a professor and the head of Department of Management of Technology of University of Moratuwa, Sri Lanka. He was served as the visiting faculty for MBA and Master of Engineering programs in several universities. Professor Perera holds a bachelor degree in mechanical engineering from University of Moratuwa. He obtained master's degree in manufacturing systems engineering and doctoral degree in industrial engineering from Asian Institute of Technology. Professor Perera has contributed to numerous technical papers in both international and local journals and conferences. He has been presented the Award of Appreciation for Outstanding Research Performance by University of Moratuwa from year 2008 to 2011. Professor Perera has served to the industry as a consultant in engineering and management. So let me invite Senior Professor Chandana Perera to share his experience with the Industry 4.0 initiatives in Sri Lanka. Chandana, you have to unmute. Yes.
Thank you, Mr. Kirti, for your introduction. I think you can see my screen.
Yes, yes, can see.
In this session, I would like to present my observation in Industry 4.0 initiatives in manufacturing companies in Sri Lanka. We were able to hear some case studies overseas, but we can see what we are doing here. First of all, I would like to mention some of the challenges we face basically. We have demand side challenges, increased variety, small lot sizes, shorter lead time, and also supply side challenges, labor shortage, and increased labor cost, and also longer lead time for materials supplies. To overcome these challenges, some of our companies have introduced Industry 4.0 technologies. I was able to observe some of the sectors in Sri Lanka, among them apparel, food and tire industry are prominent. Not only technologies, actually, not only technologies, I was able to see some new job roles in these companies. When you talk about the new job roles for Industry 4.0, they are not at the lower level. Even I can found certain job roles at the director level, process automation and digitalization director, process automation and digitalization manager in the middle level, digitization engineers, mechatronics engineers, and new job roles in data analytics. This is somewhat different from traditional IT professionals. Then this is very essential for implementing Industry 4.0 technologies. Many of the companies who are willing to introduce Industry 4.0 technologies have introduced these job roles, especially apparel, I was able to observe, and also tire and food sector. My experience in apparel sector, I was able to find technology initiatives in two sides. They have hard automation and soft automation. Hard automation for material processing and the movements of the parts, and soft automation for design, planning, and system integration. When we talk about soft automation, integrated manufacturing is a prominent one. There are many areas like R&D engineering, asset management, manufacturing, supply chain planning, supply chain logistics. In all of these areas, they implement sophisticated software technologies. But what I noted is, even though they have sophisticated software technologies, integration is somewhat lagging, but they are aiming for that. Especially nowadays, many apparel companies, they have very sophisticated software in all of these areas, but they are looking for further integration. Not only software side, even shop floor level, they have some initiatives. They have real-time data capturing and on-board. This is very important for improving the productivity and also increasing efficiency, visibility, and accountability. Right? Then workers can see what they are really doing and whether they have achieved the target, and what is the level of the machines, whether it is properly working or malfunctioning. If it is malfunctioning, maintenance crew can attend for the correction, and also the productivity levels, the quality levels, all these are visible to the workers. This is achieved through real-time data capturing and displayed the present level in the display boards, known as the and board. This is another activity in I noted in apparel companies. Many of the companies have gone to lean manufacturing and just-in-time implementation. Now, traditional card system, Kanban, were replaced by e-Kanban with the help of QR and barcodes. Now, instead of the traditional cards, they use the barcodes and QR codes. This facilitated the bin management, but still these companies have not achieved the level of full integration in the supply chain. They are doing in the shop floor area, but e-Kanban ultimate goal is apply it in the all level of the supply chain. But they are working towards that direction. Again, another area is finished good management. Once the production is completed, this finished good should be sent to the warehouses. The traditionally what happened was the transporters look at the bins are filled. Now through digital screen, they can identify which line has completed the production, and according to the production completion, they transport the finished good to the warehouse. This is through this they were able to save a lot of manpower. Not only manufacturing area, even in design, they use the high-tech related to Industry 4.0. The technologies like augmented reality. This use computer vision for fitting and design. This will immensely reduce the design lead time. That can reduce the delivery lead time of the product. The companies are going for this direction, especially in the apparel sector. Even other companies can look at how they can reduce their design lead times using the novel technologies used in Industry 4.0. Another area I was able to observe is predictive maintenance. Sophisticated IoT-enabled predictive maintenance, Internet of Things, sensors and detectors detect the status of the manufacturing machines, and those are reported to the operators through cloud and data analytics, operators and the maintenance crew. Then they can do predictive maintenance based on this information obtained from the sensors. This is a new area recently introduced in some of the plants. This is anyway not widely practiced, but few plants are working in this area. Some of the apparel companies have replaced their traditional trolleys from automated guided vehicle. Through this, they can transport their finished good and work in process to required destination. Through this, they were able to reduce a lot of manpower. That will be a solution for labor shortage. This is actually a material processing or material movements area. These are some, what I mentioned is some of the technologies presently used by the companies. Industry 4.0 technologies presently used by our companies, but there are many areas they are considered. The artificial intelligence for shop floor operation, machine learning for logistics, 3D printing in design stage, robotics for packaging and distribution, real-time production and part tracking. These are some of the areas they are looking for. I hope in near future they will achieve those technologies. They will implement those technologies, but they need real assessment and understand where they have to go rather than arbitrarily implementing the technologies. I hope within a few years, our companies, many of our companies can implement many of the Industry 4.0 technologies apart from the technologies they have implemented so far. Thank you. That's what my experience I have to share with you.
Thank you, Professor Chandana, for your valuable insights with the local experience. I think most of his experience comes from the garment industry. I think, you know, he showed us finally there are a lot of opportunities in many areas, which can be it can be low hanging or high hanging fruit, but however it is, you know, there is a opportunity for us to go for it. So let me introduce our next speaker, Engineer Sena Piris. Sena Piris is a mechanical engineer from University of Peradeniya. He has over 25 years of experience in the manufacturing industry in different capacities. From late 90s, he became an environmental engineer specializing in the area of cleaner production. He was the founder director of the National Cleaner Production Center in Sri Lanka. Now he works as a director of business and industry development service, providing consultancy on energy and sustainability. He is the chairman of the National Expert Committee on Climate Change Mitigation and president of Sri Lanka Responsible Care Council. So let me invite Engineer Sena Piris to share some of his experiences and address the opportunities and the challenges in Industry 4.0 implementation in Sri Lanka. Sena, over to you.
Thank you, Kirti. I hope you hear me clearly.
Yep. Yes.
Let me share my presentation. I won't take much time, very short. It's important for us to understand where we are, especially related to how we are moving towards circular economy, how I4, Industry 4 can move us towards circular economy. First of all, I would like to say during the last 20 years, a large number of industries have moved from where they were very primitive to a current level. At that time, we were actually probably were at Industry 1 level, and a few years they spent in improving their process. They use cleaner production, energy management, and many other approaches. And many industries during this time have moved to advanced technology using instrumentation. I remember when we started introducing cleaner production, most of the industries were using manual controls, even for water level or even for temperature and even for pressure. Even large companies, what we are talking today, who have gone to automation, were doing this manual control. They have moved to this level, and a lot of skill development has gone up, has gone into this work, and the process efficiencies have improved. And because of this, we looked at why we are having this problem in the country, why we are not moving forward. We saw a lot of major efficiencies. Number one was actually the addresses issues in isolation, and then mostly the low adequate skills and inadequate attention to process control. This is one of the key areas, the skill level and the process control. These are problems most of the industries were having, still they are having them. And then we don't have this culture of monitoring, measurement, and record keeping. There are a few industries who are doing this very well, but there are many industries who are still lacking. Then we have production focus. We have no maintenance. We do breakdown maintenance. We have no predictive maintenance or even preventive maintenance for that matter. This is changing a little, but also another important thing, we are actually still competing with the neighbor rather than with the neighboring country, with China, Vietnam, who are the real competitors with us. And unfortunately, most of the industries who have started with innovative ideas, they are designed to fail when the need for expansion, their market expands, and then go for over-trading without having proper understanding, and they fail. So the current challenges are actually the globalization, which we have. Today, it's not only quality, price, and delivery. We have to look at the environment and social concerns. And today we call the low carbon and resource efficient manufacturing is very important. So the circular economy has become very important as a result of that. To add it to that, the COVID-19, the business have become completely changed. Are we ready to go for the new normal? So these changes have to be actually incorporated in our activities. So the natural resource depletion and global environmental degradation are problems people have to pay attention. The resource flows are very important. Then there are a lot of errors people are making. Making errors and creating rejects are no longer an available path. We cannot have rejects and errors. Then end consumer products are no longer a waste. We have to understand the end consumer products, or what we call waste today, are a fortune in disguise. So we need this to be changed. We need a new paradigm with new strategies, maybe even new business models. The transformation requires elimination of human errors and mistakes. And we need to go for instrumentation automation, improving the process control. It can be achieved through mostly instrumentation automation, maybe even data. And then we have to integrate resource optimization with big data and IoT, and go for sustainable supply chains. We need a lot of new tools, because especially scheduling, when you go for new supply chains, you need e-Kanban and cloud computing and many other tools like that. Because today, meeting an inventory, keeping an inventory is a luxury. We cannot do that. So the Industry 4 has enabled the circular economy. We can see now, as a result of this Industry 4, we can eliminate most of the waste treatment. I think Professor Ramanathan said most of the waste is actually can be recycled and it can be incorporated into manufacturing processes. And we can go for decentralized manufacturing, a global manufacturing system. We can go for green supply chain with that. And then mostly Industry 4, mainly computerized manufacturing and many new tools give opportunities for industries for dematerialization and decoupling. We know 3D printing was actually something like that. So the dematerialization reduces our material consumption. And then companies can apply a lot of innovative solutions. We can go for interoperability and flexible industrial processes and automotive and intelligent manufacturing, which all lead to resource optimization. So all these Industry 4 tools and approaches and strategies can be supporting circular economy for us to move towards a low carbon, resource efficient, and socially inclusive world, which can be a sustainable world. I think with this, I will conclude. Let's work towards making a sustainable world. Thank you.
Thank you, Mr. Senapiris. I will, since we are almost, behind the schedule, this should be the time we should conclude our session. But however it is, we have some questions. We have only one last speaker, Nihal Kure. So let him speak, and after that, we will take some questions. Our resource panel agreed to stay a little longer, but after this one, probably we can conclude, and some of the people who wants to leave our session can leave, no problem. But if anyone wants to raise any questions or get clarifications, they can remain. But in the meantime, I have put our feedback form into the chat box. It's just a very simple Google form. We really appreciate your inputs on that, because when we're trying to plan a future session, this will be very useful for us as well as for the resource people who made presentations. So let me introduce Nihal Kure, who's going to be our last speaker. Nihal is a graduate from University of Ceylon. He obtained BSc Honours in Mechanical Engineering and postgraduate diploma in Industrial Engineering from Open University of Sri Lanka. He's a chartered mechanical engineer of Institute of Engineers Sri Lanka. He's a director of Business and Industry Development Service Private Limited. He started his career at Ceylon Cement Corporation and over 40 years experience in public and private sector. He worked with the Project SMED at the Federation of Chamber of Commerce and Industry Sri Lanka. He has done numerous projects there, from various cleaner production initiatives to greenhouse gas emission projects to Tsunami Back to Business, and many projects for his credit. He is a member of the National Industry Policy Formulation Committee too. So let me invite engineer Nihal Kure to share his thoughts with regard to the opportunities and challenges in Industry 4.0 implementation in Sri Lanka.
Thank you very much, Mr. Kirgunodana. And also thank you, Dr. Rama, for that kind words, and also it's a real reunion. Actually, I want to go through my topic by really going to my history. When I started working at the Ceylon Cement Corporation in 1974, I actually observed that we had a very good kiln. It's a semi-automatic kiln. But after about like 25 years, when I went there to do a GHG emission reduction program, I saw the same kiln operating a fully automated, fully integrated factory, giving high quality products, and also the production rate was very high. So then I moved to Ceylon State Hardware Corporation, the state corporation, and I saw that although people were capable of doing certain things, but anyway, the automation level and the level of advancement was very slow because of so many reasons. But yet there was some interesting case study. For example, I remember machining a very large tube making mold for die operation using a horizontal boring machine, which is normally not normal. So anyway, there were genuine attempts to go for advancement of advancement in the industry. Then when I moved to the private sector, I saw how different it was. Especially, I went to another mold making and a plastic industry, where I saw at that time, 1980s, how the entrepreneur, the owner has invested in very high tech machinery at that time, and some people thought why they really did that. But then we saw how the results came later in the production of mold making and other things. So anyway, there was a gradual advancement, but there were gaps also. And then when I really worked at projects made FCCISL, I had the opportunity of working with the SMEs, and I saw that SMEs really lack a lot of things, although it was very slow and they're highly undercapitalized, and due to so many reasons, maybe technological or maybe financial. But anyway, now I see the trend is there are some interesting trends. For example, I have seen the die mold industry, which is really close to me, close to my heart, moving very well, and then they have invested in very good machinery, even SMEs. But there are certain other problems that we have to think about. Now, I will be very short in my presentation. One thing that I want to tell you is that manufacturing industry is not a standalone, like this standalone thing. If you want to run a manufacturing industry, you have to, especially in the circular economy or working with the supply chains, you got to get all the stakeholders involved. For example, I mean, the supply chain itself can be like starting from product design. So there are so many I can imagine how much the integration and involvement is required for the manufacturing industry. One important thing is that when you want to do your the circular economy, in the circular economy supply chains, it is important that all the different components try to achieve a sort of a similar or same level of technology advancement. Otherwise, there will be gaps, there will be constraints. And what I see is that Sri Lanka has a very beautiful and sometimes beautiful, and also I have seen the supply chains, value chains, which are very beautiful and also ugly. So what we have to do is to make the beautiful more beautiful and the ugly also more beautiful. So that's the key thing that we are aiming at. So, but we are now actually, this webinar is being conducted at a time when the National Policy for Industry is being formulated by the Industrial Services Bureau, with an eminent team of experts in order to make our industry globally competitive. The policy had adopted transition to a circular economy and Industry 4.0 as important policy principles. So without taking much of time, I would like to, actually I am happy to, and it's an honor to invite Professor Aditya Dialis, who is in our midst, to speak a few words about the policy direction. He is the Dean of the Faculty of Graduate Studies at the University of Borough, and he is the key expert in the policy formulation team on knowledge-based and creative industry, digitalization, and transformation into Industry 4.0. Please, Dr. Professor Alice.
Thank you, Mr. Kure. Thank you. I'll be quite brief, but thank you for the opportunity. But it's good to hear Dr. Ramanathan after so many years. Initially met at Slintech and coming across, but I remember Mr. Kure sharing this particular evaluation document with the industry policy team and saying this is quite important. And I mean, definitely believe it. But I have just one question, whether we can also tune it into from a self-diagnostic one also to a like a walkthrough assessment to, scheme as well, making it like looking at a perception, like looking at from perception basis and turning it into a walkthrough assessment tool. Should be possible, I believe, and that may be helpful because the self-diagnostics, the honesty, and so on actually needs more engagement and time. So may help us by converging that. With the industrial policy, I mean, when you see the level 0 to the levels that you have articulated in the assessment, our policy, yes, when we were requested to do this, there was this push for Industry 4 by the Ministry of Industrial Industries. Actually, they placed that in the terms of reference for the process, and it's well within. And so we have actually included 2 policy directions, policy principles, along converting in the industry to the Industry 4, as well as creative and innovation being brought into the industry scene, because we believe that you need 3 things. I mean, you need technology, you need innovation, you need talent. This is perhaps 3 pillars under which this network readiness index has also been developed globally. So in this assessment, so the situation is there's a lot of distance to cover by the Sri Lankan manufacturing industry. I can kind of visualize when we see a tile factory or even a tea factory, where we are with respect to looking at the Industry 4 and the type of situations that we need to develop. We have in few segments, it's really, I mean, somewhat embedded. And we also have taken steps by introducing this Center of Excellence for Robotic Applications. The primary motive behind that, it's there now. It's there in the public system. It's moved into a company status and promoted to solve, get this robotics, AI, and these into the industry manufacturing sector. That's a primary objective of the Center of Excellence in Robotic Applications. Already Costi worked on. It's been pushed and it's there. And also there was another mechatronics system, that mechatronics-based development that has now been looked with Nerd Center, where there was this support for the manufacturing industry to enable them for certain products development and certification and so on, because individually they are not in a position to invest. But we thought with public support in one place that they can come and utilize these technologies and standardization schemes and so on. So they have been, they are both now available on the ground, but needs a little bit of more push to make it more be visual to the industry sector and for them to come and utilize. That is a little bit still awaited. Foundations have been laid, instruments, people have been pushed, moved around into that. Yet what's missing is still the visibility part. So hopefully just to Mr. Kure asked me to mention on this industry policy. Yes, industry policy is there, but the point is sometimes our industry mindset, the manufacturing mindset in some sectors are still nowhere close to industry 4 thinking, and that is where we have this problem of getting people manufacturing moved in this direction. And it was a very interesting thing to see about this Adidas, the speed factory, the concept, and then what they have now really leveraging on. Okay, now we moved away, even not looking at these intellectual property aspects, moving into locations and benefiting from the technology and benefiting also from the low-cost labor. I mean, it's completely different thinking. It's again useful to us to think along the direction, and that possibility still exists. So as it was mentioned by Dr. Ramanathan, it enables us to probably leapfrog in some way if we really embrace, but moving through the technology and the skill set, that's important. So that's the short introduction that I can show. It's in industrial policy. We have started embedding that seriously, and that's it. Hopefully, we will get traction. We will get this policy accepted, and if that is good. And you saw we saw the power, and definitely we'll use this the template in moving forward. Thank you, Mr. Kure.
Thank you, Professor Ajit, coming forward on this one and on the request of Mr. Nihal Kure. Thank you for your great contribution. So we will take up few questions. You know, there are a couple of questions. Some are little long. I will make it short. Mr. Yusuf Salim is asking a question from Dr. Ramanathan. He's asking about vertical networking. You know, his major question is, you know, connecting all the machines, you know, machine being connected. And his question is, in the industries which are more labor intensive, like apparel, activities involve informing being connected, can someone give a bigger business impact at the start of the Industry 4.0 journey? Any thoughts that you can share on the same? Rame, you can answer. Or is that is that clear to you or not clear? He's asking.
It's not very. Could you please repeat it again? I couldn't quite get
What he's asking is, you know, we are talking in the 4.0, all machines being connected and vertical networking. He's asking whether in a apparel industry or someplace, I think, you know, Professor Chandana's presentation gave some insights already to his question. What he's asking is that a possibility? And, you know, do you have any things to share with him?
Yeah, my quick response is that one of the reasons why we talk about vertical integration among machines using Industry 4.0 is we don't want to have a lot of work in progress or work in process between machines piling up. So when machines are interconnected, a lot of the bottleneck problems, a lot of the work in process, many of these things get eliminated. But it is just not a question of connecting the machines. We also need to have a very good information system and integrated IT system. That is why I mentioned the use of having these various data collection at the shop floor level, using a variety of sensors and programmable logic controllers and other possibilities. There are ways of collecting that information. And then that can be used for manufacturing execution, using the manufacturing execution system. Then you are able to really get the best out of the vertical networking. So that is the direction in which we want to move, but it is progressive. because sometimes when you have a very labor-intensive setup, where the machinery, everything cannot be easily upgraded to make it possible to vertically integrate, you might have to actually set up a separate operation if you want that vertical integration. That's why there are some researchers and consultants in Industry 4 who have pointed out that if there is a very large organization and if your existing operation makes it very difficult to actually move into an Industry 4 setting because it's very labor intensive and the equipment is old and so on, sometimes it is better to think of what they call a greenfield operation, where you set up a completely new facility, like what Salomon is doing in France, because they also have existing factories, but they feel that in the existing factory, it would be very difficult to do all that. So they have actually moved into a completely new place, and they are setting up this, what they call the Advanced Shoe Factory 4.0. So it is very difficult to generalize. One has to look at the existing operations to see to what extent vertical integration can be done in a cost-effective way, and then move towards that in a progressive way. If it is very difficult to do it, maybe the only other option is completely go for a greenfield kind of establishment. So I'm not too sure whether I answered the question, but
yeah,
it's a very important but very difficult question to answer.
Yes, yes. Yeah, like, I mean, he
I can add something to that.
Sure, Chandana.
Even though the machines do not have the capability for fully integrated, sometimes the operators are given the tabs and those are connected to the system. The operators can enter what is actually happening. Sometimes the machines are not capable. In some cases that also happen. That way they pass the information to other parties, the status of the production and so on.
Yes.
If that can be connected to the machine, that is the ultimate objective, but some of the existing machines we can't replace.
Yes.
And it is a huge cost, but initial phases we have to follow some kind of methodology.
Yes.
The information is the most important.
Yeah, understand. You know, like, I mean, using the current equipment and using some kind of data from outside to inside, you know, that's the method that you're proposing. Then Gamini Senanaik is raising a question. With the adoption of Industry 4.0 by technology advanced and developed countries, will the emerging economies and developing countries have to continue to export their resources in raw form or additive manufacturing?
Yeah. I mean, that's a very interesting question, Dr. Gamini. And I mean, Gamini and I have worked together when I was with the United Nations and all that. And it's a delightful person to work with. So the question is equally delightful. See, this is, I mean, I consider this very analogous to the old situation when in Sri Lanka we were exporting our sheet rubber and crepe rubber and then buying back tires. We moved away from that and started adding value to our raw materials locally, started manufacturing tires. The same thing happened in the tea sector. I'm talking about what happened in the 1970s and so on. So I have, my feeling is that if our companies develop the necessary Industry 4 expertise, and today 3D printing technology is actually becoming very, very popular throughout the world. In fact, I have a German friend with whom I worked on this Industry 4, and he pointed out that in Germany, small bakeries are using additive manufacturing to actually make the cake you want. they actually have designed special equipment where you can use the basic cake, and the customer can decide what design and what toppings they need on the cake, and the machines make it for you. So it's individual customization done very quickly. So the reason I'm giving that example is 3D printing today has advanced dramatically. So depending on the raw materials that we are exporting, we can see how best we can add value to that in our country itself and send the finished product to the buyers rather than doing it in a different way. And it might actually be more attractive to the buyer, because if you have low-cost skilled labor in our country, and if we can use this technology to produce these goods, it will be much cheaper for the buyer as well. Yeah. So as the Professor Alvis talked about the case of Adidas, they have moved to China because there they have low-cost skilled labor and the manufacturing capabilities. So they are seeing an opportunity there. So if we also develop those capabilities, I think we don't need to export the raw materials. We can actually add the value in Sri Lanka itself and send the finished product. So that's my personal view on that.
Yes, thank you, Dr. Rama. I think Dr. Gamini, you know, we also as a team, we believe Sri Lanka has a lot of potential. That's why we started this initiative, not to, you know, send this raw form any longer and to make more value additions. I think, you know, we have, as he mentioned about the rubber industry people with us in this forum. And people who into tea companies are here with us. I think, you know, they have done a greater value addition. I think some of the other raw materials, but we have also, we have to go in for production and, you know, from there to value added productions. Then we have another question. And, you know, we have a raised hand from Mr. Daratnasila before that. So let me finish. You know, there is a, I think we should not go in for that one. This Adidas, you know, there are questions and, you know, recommendations and, you know, opinions and things like that, whether the ROI can be recovered and that kind of confusions. But however it is, as Dr. Ramanathan mentioned, so that's a possibility. You know, even today, if you want a cake with your picture, you know, they will print your picture on this one and give. Even to a coffee, you know, it can be answered. So the technology is available. Then another, I think, you know, that's the questions that we have got. And, you know, one other thing, Arosh Jayasundari is raising question, very interesting presentation. He says, this is also Dr. Rama's presentation, to what extent are they clear enough to do proper self-assessment, since they may not have the expertise? You know, with regard to the Sri Lankan companies, he's raising the question, whether the self-assessment can be done by themselves. That's his question, I believe. I think even Dr. Prem can answer, you know, his area is covered there. Prem, you know, you have to unmute.
Yeah. Sorry, Kirti, now there is one other question you missed before that. So I was looking at that. So yeah. I think just after the question about how you can, what is the role of service sector? Someone asked that question. Nimal Pereira, what is the role and existence of service sector organization in Industry 4? Anyone can answer that? That's the question I think you missed. I was looking at that.
No, I'm going to ask that also. Before that only I asked this question. Yeah.
Okay, can you repeat? Yeah. I mean, the one you want to...
Nimal Pereira's question is, what is the role and existence of service sector organization in Industry 4.0? You can go ahead with that one first.
Yeah, I think, of course, the Industry 4 mainly targeting the manufacturing sector, but how we can get into the service sector depends what really because nowadays there is a digitalization where there is even if you look at the number of say for example the printers, they are not products they are selling, they are now selling the service. So basically this industry 4 in terms of the industry 4 readiness assessment, yes, we are looking at all of these determinants from the manufacturing perspective, but it is, if you look at the much more advanced manufacturers, they are not selling the product, rather the service. They are very much, they are providing the service in that way. So, but if it comes to the very traditional service, yes, then we need to look at the digital transformation as the key. Where I know that in Sri Lankan government, I heard this whole roadmap for digitalization. So there are certain, maybe industry 4 is a broader umbrella under which you can look at digitalization as the one area for the service sector. And that could be the focus, but still the assessment can be, yes, under which each and every determinant can be looked at from the service sector perspective. May not be too much machineries, plant and equipment. Definitely there is a human, and also the product definition is always going to be there with the service, because now there are many manufacturers who are selling the service than the product as part of the whole package. So that could be, of course, there needs to be a separate assessment framework, but it depends on how much of that service sector and what areas of service sector that we are looking at. And depending on that, could be different framework to cater for that particular service sector. But mainly this one is for the industrial manufacturing sector, and they're very specialized in terms of the determinants. But if you look at the human capital, strategy and organization, they're very much part of any organization. So it can be very much replicated in the service sector as well, but needs to have a much more service sector focus assessment framework plus the rest going forward. I don't know whether I answered the question, but that's something I think we also like to see a framework being developed for the service sector itself, but service sector also has got many different areas.
Thank you, Dr. Prem. I think you have answered quite well for that question. We have a few other questions. I think we will take them. I will post it to all the panel members, and we can write back to them. The major ones we took here, and Ms. Dr. Dayaratna Silva has raised the hand. Let me Dr. Dayaratna, you can ask your question.
Thank you, Kirti. First of all, thank you very much, the FTC-ISL for organizing this kind of, engagement, very important. I have one comment and one question. My first comment is the impact of OIR setting on international trade. Now, this impact will happen through the, what do you call, the certification of international trade through the cross-border trade, right? Cross-border trade, there are a number of, plethora of formalities, procedures involving clearance. Of course, we have this containerization, use in multimodal transport, all have helped. But OIR setting offer a unique opportunity to reduce the trade cost. The countries who apply these, the OIR setting will be more competitive than others. In very simple terms, first movers will benefit. Then cross-border trading, this is a very big topic. I will confine to that one. But my question goes to good friend. Very good to see you, Rama, after a long time. My question is now, as you know, bulk of world trade in manufacture take place through the what we call global production network. That means part and components and contribute more than, I think, 55% to the world trade in manufacturing. Now this question you mentioned, what do you call this, offshore, reshore, the link, you reshore to offshore to reshore, right? Now, my question is, with this 4IR setting, will that GPN, relevance of the GPN will diminish or further strengthen? Why I ask this question is, number of countries in this region, developing world, emerging countries, are trying to get a share of this GPN as part of the industrialization. Here, the value addition is not relevant at all. Even, the China, to Apple, only 7% contribution. Now, in that context, to what, my question is, how 4IR affect GPN and its relevance to them? Thank you. That's my question. Thank you.
Rama, you have to unmute. Rama, you have to unmute and speak here. Yeah.
Thank you, Dr. Dayaratna, for that very interesting but very difficult question. And likewise, lovely to see you. It's been several years since we've last met and worked together, but always a pleasure to see you. I think the question is extremely important, but I'm afraid that I will not be able to give you a very clear answer. The answer is likely to be a bit vague. And what I want to say is that global production networks will continue to be there. They will never go away, that's for sure. The question is, how will it get reconfigured because of Industry 4.0? I think that is the question that we need to look at. Because now, if you look at global production networks, these global production networks became a very important area after globalization of business. When countries started bringing down their trade barriers and so on, it became possible for the globalization of business. And so a country like here in Australia, where there was a lot of manufacturing, but because of the higher labor costs, it was more expensive to manufacture here. So gradually what we found here is in Australia, slowly a lot of the manufacturing started moving offshore. They did the designs here in Australia. Say, for example, if you take the woolen wear, they did the designs here, but they exported the wool, did everything. It all went to China and other places where they made the final garments. And from there, some of it was shipped back to Australia. The rest was shipped off to other parts of the world. So the analysis showed that even though the wool is made here and the design is made here, shipping the wool, which is a very bulky commodity, it still made economic sense to make it in another place like China because of the various advantages, labor costs, and so on, and export it. So the product was still cheaper, and they were able to export to many parts of the world. Now, during this COVID crisis, one of the questions that came up here in Australia was there was a big shortage of a lot of the stuff because Australian manufacturing has virtually disappeared. I'm, of course, exaggerating. There is still some manufacturing going on, but all the automotive firms here are gone, finished. They have stopped manufacturing. The automotive component manufacturing firms which were set up to support the automotive firms, they are looking for business in other parts of the world, and now they are selling their components to assemblers in Thailand and in other parts of the world. And some of them have just closed down shop because they can't export competitively. So the question that now is the Australian government is asking is, shouldn't we bring manufacturing back to Australia? Because with this big disruption in the supply chain. And then there was even this question raised, when Industry 4.0 technologies are available, and when countries like Germany and others, and even the United States are encouraging some of their firms to come back to their countries and reshore, to use those terms, and manufacture there using Industry 4. Why isn't Australia doing anything? Should we still be like this at the mercy of all the other countries? And if the supply chain gets disrupted, what are we going to do? So there's a lot of thinking going on how to encourage companies to come back. The implication is we don't have to do everything all at once and completely stop offshoring, but we need to strike the right kind of balance where each country asks itself, what is the best option for us? How much should we reshore? How much should we offshore? So that we are more resilient. The supply chains becomes more resilient. So a kind of event like COVID, if it happens, then we are still not going to be caught napping. So that is one option. And governments like that, because now if you reshore, you're giving more jobs. So that's also good for the electorate. So that's another interesting aspect for them. So my feeling, and I must confess that I have not really done any careful analysis, but based on what I have read so far, my feeling is that these global production networks will get completely reconfigured over the next decade. How it will get reconfigured, I do not know. But I think if we watch how it's going, we may find some patterns. And I'm sure, Daya, you know better than me, that Japan is now, Japanese government is giving billions of dollars in support to a lot of the local companies to do some reshoring using Industry 4.0, because their supply chains got quite disrupted during this COVID. So they feel that they can't have this kind of situation again in the future. So throughout the world, you see governments are beginning to, this COVID-19 has also, I think, given an impetus to using Industry 4.0.
Thank you, Rama.
Thank you, Dr. Rama. I think, that I will go for the next item in the agenda. That's the concluding remarks. I think we have come to a nice conclusion with Dr. Dayarasna's question and Dr. Ramanathan's answer to that. I think, with the COVID situation, many places, there was huge disruption in supply chain. So now some people, even, we think in Sri Lanka, we should have everything within Sri Lanka kind of mentality. So that's also one thing good for 4.0. Okay, if that is the case, if you can manufacture profitably, efficiently, so that is one kind of bottom line for that particular country. So if that is the case, that's the reason that you mentioned Japan and Australia and Germany, many other countries, they're trying to invest a lot of money into this area to try to support a lot of private sector organizations to come up with 4.0 initiatives. Now they've gone beyond, and they're talking even 5.0 now. So now for us to think, whether we are late or whether we are early. Some people think, we are early. Of course, I would say we are not late, but of course, it is time that, we have to immediately get into this. But if you really miss the bus, we won't be able to catch up. That's what I can say. Now, this particular initiative of us is an initiative that, we are trying to bring all knowledge and, expertise together and, try to take the horse to water. So it's up to you to take it, we are doing from the chamber side as well as Dr. Prem and Rama from the Sydney University side, and the Professor Chandana from the SLIT, and this is a nice collaboration. I also feel many people have commented even on the chat box. I see many good comments. So this we can continue definitely. This country, we should be prosperous in our country, and all industries where we have in Sri Lanka should go to the next level, and they should achieve Industry 4.0 and make more productive organizations. So let me invite Mr. Ajit Perra, who's the Secretary General of the Federation, to make the vote of thanks officially. Until then, so let me thank you that I do not think that I will have a better panel of experts than what I have today to moderate another session. Dr. Rama, Dr. Prem, Professor Chandana, Seda, and Nihal. So it has been a wonderful panel for me today. So let me invite Ajit to make the vote of thanks on behalf of the Federation and behalf of the entire committee.
Thank you very much, Kirti. Hope you can listen to me.
Yes, can.
Okay, thank you very much. I think this is a very great initiative by FCCISL, and I must very profusely thank Kirti, the SVP, and also the organizing committee at FCCISL, and also all the speakers who gave very modern and very futuristic and trendy the business philosophies and what's happening all around the world. So this is actually, I think, maybe the first time the Sri Lankan business community had the opportunity to listen to this, these experts' comments and also views. I think we, as Kirti said, we should continue this exercise and we should not stop at this stage. And I also, I feel that this type of new business re-engineering processes and also using the high-tech and how we could basically a developing country like Sri Lanka, how we could get the best advantage, and also how, what are the challenges the Sri Lanka is going to face in bringing these initiatives. I think that's true. Also, we have to look at the any future the webinars. I think the idea has been very well orchestrated by all the speakers. So all my thanks to all speakers. Since we are a little bit behind the schedule, I want to basically shorten my vote of thanks. So it is all about these efforts, and also I must also say that the sparkling question asked by Dr. Dayaratna, who is my good friend, about the certain aspects and all the challenges actually what we are going to face. And also in person, I believe, as a person who gets very much involved in the Asia-Pacific trade, it's when some governments are trying to pull back their manufacturing plants from China especially, but also we should not forget the fact that China is also very active and aggressively entering into the free trade agreements and also giving more benefits to their investors, and also especially to some countries, especially under a Belt and Road Initiative. So this basically certain practical and the challenges also I believe that we will have to face. But all these, once again, the things are good for discussion, especially at the new the forum. So I wish all the speakers should think that we should have another series of like this, and how the countries like Sri Lanka, especially when we are struggling due to the pandemic, and also the sustainability of these challenges, and also to how to overcome. I think this is what the Sri Lankan business community would like to hear. I think that we have a lot of scope in this, and I like to request Mr. Kirti Gunawardena, our Senior Vice President, and the team to organize another one like this and to see how we could move forward. So all in all, it's a very great effort and great thoughts. So I'd like to thank everybody and all the speakers and also the participants for your enthusiasm and interest. So thank you very much, and stay safe. Thank you very much.
Thank you, Ajit. You know, I informed you before, I have put to the chat box feedback form. We will, you know, whoever of you can answer, please do that now. And, you know, you can quit. You know, if you cannot do right now, we will send again to your email addresses, and please give us the feedback, which is very essential for us to know whether this program is really meeting your requirements, or whether we have to change the direction. So I think, you know, I should be very thankful for the patience of the participants also. We are at the peak, you know, we had 90 plus, and now also still we have 38, you know. We are really happy to see your active participation, and we will come up with other programs in the future, and we will update you. So let me again thank everyone, the panel and the participants and everyone, for this great initiative. Thank you so much.
Thank you, Kirti.
Thank you.
Thank you.
Thank you. Thank you, Kirti.
Thank you.
See you.
Thank you, Kirti, and everyone.
Bye.
Love.
Bye.
Thank you.
Bye.
See you, Dr. Rama, and others. Same.
Thank you.
Thank you.
Thank you, everyone.
Thank you. Nice to show you.
Yeah, thank you.
Thank you, Sarah. Thank you, Neha.
Okay, then
Thank you.
I'll end the session. Thank you.
Okay.
Bye.
Thank you, Kirti.
Thank you.